Hello, 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 folks. How we doing? I hope everyone is having a good Wednesday. It is Wednesday, right? Yeah, it's Wednesday. I hope everyone is having a good Wednesday so far. This week seems to be going really quickly. I don't know if it is for anybody else, but this week has been nuts. I don't know why. Your Wednesday, hi Chris. Your Wednesday is doing okay. Yeah, it's just wild. It's half over already. Hey, Scotty. Hope you're having a good day. All right, we'll get started in about 1 minute. Want to give folks a chance to get through those lovely pre-roll ads. React got me like, this is fun. Yeah, well, that's why we're starting on it now, right? That's why we're going through the docs now. We're getting familiar with some of the vocabulary, right? Just some of the terms. So that way, when Leon talks about them on Thursday or next Tuesday or whenever he decides to talk about it, you can go into it already knowing some basic definitions of things. It's like we don't have to really understand even how it works yet. Just kind of knowing, like, oh yeah, I know what props are, and oh, I know what a component is, and um, I know kind of the basic idea behind state, right? And I think that's, perfectly fine level understanding at this point. Hey, fat cat with a hat. Alrighty. The timer has wound down, and so let's get into it, shall we? All right. Hey, Rascal. Hey, Robert. Yeah, I've got new transitions. I know. I was messing around with them. Uh, yeah, Twitch Studio. I love Twitch Studio. Yeah, fancy watery whoosh. Yeah, Twitch Studio, man. All this stuff is built in. It's not like I don't got to install anything. It's all built in. I can just like pick what I want without having to think too hard. I like it when I don't have to think very hard. Super weird, it's decided to show me all of my like followers since my last stream, flash them up on screen. I mean, that's fine with me. It's just like, okay. Hey, Laylo, welcome. Yeah. So today, what are we going to cover today? Well, probably not the most exciting topic in the world, but an important topic. We're going to keep going through the React documentation that we got a wonderful start on last time. If you haven't seen the previous stream, I would highly suggest going and watching that. We cover a lot of the basic topics around React, like the basic definitions and vocabulary around React. And we do a tutorial where we apply some of the concepts and see how they work. And now we're just going to finish out the that chapter today. And learn a little bit more about some of the things that we're very familiar with working in HTML, such as like arrays, or sorry, I meant lists, and forms. Some of the things that it's our bread and butter when we talk about HTML. Lists and forms are something we use in almost all of our apps. And now we're going to learn, okay, how does that work with React? How does React treat lists? How does React treat forms? And forms are particularly interesting, right? Because forms have some built in behavior. When we talk about forms as an HTML tag, they have some built in behavior that already exists within them. And so, how does React handle that? And then we'll also talk about, again, we'll talk about state. And something that we kind of did in the tic tac toe tutorial that we did last time is we talked about taking state from inside individual components and doing what we call lifting state up to a parent component so that one component can manage multiple child components underneath it. And so we're going to take another look at that. Um, and yeah, I mean, we'll just see kind of how, like, we're going to take our time. We're going to kind of see how this goes, how long it takes, and just kind of play it by ear. Um, and I do have kind of a hard stop today. So we're going to try to actually time the stream out. We're going to try to go 3 hours. So starting at 7 p.m. Eastern, we're going to try to go until 10 p.m. Eastern and then call it at that time. So I'm hoping we can just get through the rest of this chapter. We're going to do a little bit of review of just the basic React concepts, some of the basic vocabulary, and then we'll finish the chapter. So we'll see how much we can cover in 3 hours. I'm hoping we can just finish out this chapter and then wrap this bad boy up and then feel really good for Thursday. Um, hey, Tucker Tech. Hey, Thirsty Pooch. Hey, Champo. Hey, Freshy. Checking in. The best way for you to check into my streams is to make sure that you're following me on Twitter and, like my tweet on Twitter. I'm not taking attendance though. Hey, Jim. Longest stream yet. Got it. No. No, definitely not going to be the longest stream. But I'll be real. I'm trying to be a little bit kinder to myself when it comes to my sleep schedule. So I have a pretty terrible sleep schedule. I imagine, like many of us do. I am very much a night owl. If you didn't guess, I am very much a night owl. I like to go to bed. I like to stay up really late. But then I forget about future me that has to get up for work the next day in the morning. And so future me isn't very fond of late night me. And so I'm trying to be a little bit healthier in that regard. I mean, I do work from home, which helps, but still not the best. So I'm using, my Fitbit to keep me honest, tracking my sleep, and trying to do a little bit better about that. Hit that notification bell. Oh man. I think you all have my permission to unsubscribe if I ever say, like, smash the like button, hit the notification bell. Yeah, I think I give you permission to unsubscribe from me at that point. What's the schedule you speak of? Never heard of it. Yeah, I don't really have a schedule, and so the idea is to try to make one. It's hard, but we got to try. We got to start somewhere, right? Okay, so let's go ahead and get started. Because we are on a schedule, right? Sorry, here for the long haul. Hey, that's totally cool with me. All right, so let's just let's do a quick rapid fire review of some of the things that we talked about last time. Basically, just some of the vocab and general concepts. Oh, and also today, I mean, assuming we get a decent number of viewers, I'm going to kind of play it by ear. We might also do another kitten cam. Also, especially if Xenomorph shows up. I don't know if they will, but if Xenomorph shows up, they indicated that they might want to name a foster kitten. And so if Xena shows up, we're gonna do a kitten cam and let Xena choose their foster kitten. So the foster kittens are back from the shelter. They're in the house literally. And so if Xena shows up, we'll do a kitten cam. If they don't, that's fine. We'll do it on the next stream. It's all good. Hey, Athena. All right, so let's go over a few concepts, some of the things that we talked about last time. All right, so React. So we know that in general, React is a way for us to make responsive UIs. Responsible. When I say UI, I mean user interface. Responsive user interfaces with individual components that can update independently. So up until now, we've been really used to making pages using like templating engines and that kind of thing, which are fine. We can pass data to our templates from our server side. But the drawback to that is that every single time we make a change, we have to either do a redirect or refresh the whole page, right? Each time even if we add one single list item, even if we submit one single form and add one item to a list, we refresh the whole page every single time. And so the cool thing about React is that we can have sort of components that work independently or components that work together and change themselves depending on whether something inside of them is being altered. So we can have individual little puzzle pieces on our page that change themselves only when they need to, which is pretty cool. And so last time, if you remember, we looked at the example of a ticking clock. So on the page was a ticking clock, but then when we did an inspect on that clock, I think I can find it here. We did an inspect right here. So if we look at this, we did an inspect on that clock, we could see that the only part of the page that was actually updating was the clock itself. So the whole page wasn't reloading every single time. All of the rest of the HTML wasn't being updated. The only thing that was being updated was the clock itself, right? And so that's pretty cool, especially as we get into more, complex and resource intensive apps with lots of multimedia and lots of images. We're going to want to be more cognizant of how we use our resources, right? And so this is a good way to do that. Um, so how do we write React? Well, we write React using a syntax extension to JavaScript called JSX. And the lovely Mavi Sunshine shared with me a great meme on Twitter, which I think encapsulates the idea of JSX pretty well. And it's this. So if you take HTML and JavaScript and they have a baby, what you get is JSX, or at least how it looks anyway. Yeah. I thought it was pretty great. I forgot to show it last time. So, Mavi, if you're here, sorry. I really did want to show your meme because I think it makes a lot of sense. Yep. And by the way, Mavi Sunshine on Twitter also makes some great infographics and things like that around React and JavaScript and coding concepts. So, Mavi Sunshine, pretty good follow on Twitter if you're into that kind of thing. So, yeah, JavaScript, HTML makes JSX. And like I said, that's how it looks, right? And so what JSX basically is you're basically writing what looks like a combination of JavaScript functions and HTML tags. Now, what that renders to under the hood looks much different than what you're actually writing, but on the surface, it's a great way to combine our knowledge of HTML and JavaScript and smash them together. Yeah, and Jazzy Pants there shared a link to Mavi's Twitter, so feel free to give them a follow if you want more knowledge drops like that one that I just showed you. Okay, so JSX is what we're writing in. And so yeah, we're writing in JSX, and we're using the sort of JavaScript concepts that we're used to, such as functions and arguments. Although when we're writing in JSX, we generally call those components. So what we would consider a function in plain JavaScript, we call a component in React. And what a component consists of is essentially a full function or a class. So function or a class, which accepts what we call a prop. And so standard JavaScript functions accept data as arguments, right? So we pass an argument to a function, and the function takes in that argument and does stuff with it. Whatever it does, it's expecting some input data, and it takes that in. It's ready to accept it, and it's prepared to transform that data in some way. And so with React, we call those props, and we can pass those in. For example, in this simple function right here, this simple component is the component itself is called welcome. And what it does is it takes in a prop and it returns an H1 tag with someone's name in it, right? And so what we would be passing in as a prop is someone's name. And they also show us, we can use classes to define components as well, and which in this case basically does the same thing. So we have a class called welcome. We're extending the base React component class, and we are returning exactly the same thing. Um, Now, where we get into some differences is when we start to incorporate state. So essentially, what is state is like a snapshot in time of the configuration of a particular component. So when we talk about, we can think about it in the terms of the tic-tac-toe board that we looked at. Um, so when we drew our tic-tac-toe board, we started out with just a blank grid, and it had a grid of 9 squares, all of which were empty, right? So if we think about it in terms of an array, it was like an array where all those squares, where all those elements in the array were nulls. And so we can consider that the starting state of the board. And then as soon as a move is made, as soon as somebody drops an X on the board, the state has changed. We've gone from all nulls now to a board with an X in it. So the state has changed and it's been updated. And so each time we make a move, the state gets updated. And what React does is it can look at changes in state and compare those changes to see which components might need to be updated. So that's a really important element of React, is looking at state changes to determine which components on the page should update and when. That's a pretty simplistic answer. I know there's probably more to it, but if we're just talking vocab here and definitions, I think that's a pretty good start. And we're going to do some more review of state when we talk about lifting state up. Yeah, and that's literally like the name of what we're doing, right? React. It's reacting to changes. It's looking at changes in state and reacting to those changes. And so remembering the difference between props and state is kind of important too. So props are basically just like the arguments to a function, right? So it's just data being passed in, and that data flows downward. So if we have a parent component, it can pass props down to its children. So in the example of the tic-tac-toe board that we did, we had a parent say, the parent in the tic-tac-toe board case was like, say, the game board itself. So the game board was keeping track of the overall layout of the board. And depending on the board layout, so if I click the middle square on the board and I put an X there, it could pass down an X to the individual board square. And and then the actual state of the board was the overall configuration of the board that we were comparing after each move. So we could compare it after each move and determine which components of the board to update. Hey, Interplanet. Hey, Seku, good to see you again. Okay, so any questions on just the basic like vocab and definitions and concepts before we get started? I'm kind of assuming like most folks here have watched the first stream, but doesn't mean you can't ask questions. Hey, Sunny, welcome. Oh, and two, I do want to share. Let me just share the link to this too. You should already have it. If you are a part of 100 Devs, you should already have the link to this documentation. But I will share the link here in chat so that you can follow along. Please do. The other great thing about this documentation is that it has tons of links to ktten. And that's my favorite thing about it, is that all the code in here, it's not just snippets. It's all linked on ktten and it all runs. And so anytime you're not sure how something looks, or what that code is going to do, or maybe you want to change something and try it out, you can go straight to ktten and just play around with it. And that's what we're going to do tonight as well. We're going to play around with some of this, run it, see how it works. And for me anyway, that makes it a lot easier to digest. So, okay, good deal. Thank you for the follow, Undead Guard. All right, so let's get into it. When we left off last time, we were just getting into lists and keys. And Silva says, how about CSS when working with React? Do you link the style sheet to the index page? So with React, you still do have an HTML page that you're like, you need some kind of a you need some kind of a link to tell your React where to sit on the page. And so what you still do have a div with like a ID of root, and you link your React to that div or section or whatever. So I think you would probably, I mean, I've really only done this stuff in CodePen so far, but I would think that you would still set up your CSS the same way. Um, Somebody do correct me if I'm wrong, but I believe the CSS would still work the same way. Good question though. And again, if I'm wrong, do correct me because I'm new to this too. So yeah, there's a couple different ways to do it, but you can just direct to your public folder, just like we would normally do in our full stack apps. We would have a public folder. That's where we would store our static files, HTML, CSS, whatever. And so yeah, you can do it the same way. Okay, that's what I thought. Or Program says you could also import CSS files directly into components with React. Okay, awesome. Yeah, there's a lot of flexibility here, which is really nice. From a vanilla approach where you got CSS files and use classes normally to something called CSS modules, which scopes to individual components, inline styles, ooh, scary, and a dozen different ways. Yeah, no, and I'm sure we'll definitely cover this in class. So again, don't freak out. You know, there's a lot here, but don't freak out because again, we're going to cover it in class on Thursday or next Tuesday. And I'm sure Leon, as always, will have lots of wonderful resources to help us get started and to help us understand these concepts. Yeah. Thank you for the follow, AMG. Thank you for the follow, Pedro. All right. So let's talk about lists and keys in React. So just a quick review. First off, how do we mess with lists in JavaScript? Well, I think we should all be pretty familiar with array methods at this point. Hint, hint. It's not like it's been our assignment for like the past 2 to 3 weeks or anything like that. So we should be pretty familiar. But one of the ways that we can transform a list is using map to take an array of numbers and double their values. And then we get a new array and we can log it. So that's all they're doing here. They're just taking an array, running it through map, assigning the result to a new array called double, and then console logging it. And in React, transforming arrays into lists of elements is nearly identical. So we can build collections of elements, and remember, an element is basically just kind of like what we would call like a single, HTML tag set. And so what we can do in order to do something like rendering a list of items is we can take in an array, we can use map, and then output individual list items with each item in the array as an individual list item. So that looks kind of familiar to kind of what we've done with things like EJS or handlebars, except for those we generally use something like a for loop. But in this case, since we are working essentially in JavaScript here, we can just use map and output our array items as list items with those list tags around them. So pretty slick, right? That's very clean compared to having to do like a full for loop, at least in my opinion. And then what we can do, so what we're doing here is we're creating a new array called list items, and each of the items in those array is a number inside of the list tags. And then to build the actual list itself, we can just take that entire array and dump it inside of UL tags. So that's pretty slick, isn't it? we can first generate all of our list items, store them inside of a list item array, and then wrap that in the list tags. JSX is so cool. Yeah, it really is, isn't it? Because they've made it to appear just like you're writing HTML, with the power of JavaScript functions. That's not necessarily what it looks like under the hood, but they've made it so cosmetically that's how it appears. And so we can use all these tags that we're very familiar with already, or we can write our own and make our own components and be able to reference those just as easily as we do the standard built-in HTML tags. And here's where all those suffering from EJS start seeing the light. Yeah, no, it's pretty slick. There's always different tools, right, for doing different things. And if you're not a fan of EJS, I will say I'm not. This looks pretty enticing, right? So many headaches cured. Yeah. And so this code then displays a bullet list of numbers between 1 and 5. I think this is pretty apparent, but let's just take a quick look at it on CodePen. So what are we doing here? We take in an array, generate our list items first, and let's just remind ourselves how we kind of set up that rendering. So we define a root, and what we're doing here is we're going into our document and we're getting a certain element by ID. So just like what we would normally do, for anything client-side JavaScript, we can do get element by ID and do stuff with it. And that's all we're doing here. We're getting an element by ID, and we're creating our attachment point where we're going to inject all of the stuff we're doing in React. So how does that look in just our HTML file then? So inside of our HTML file, all we have is a single div with an ID of root. So all we're doing is we're just creating an attachment point for React to grab onto, and said, all right, HTML, I'm taking it from here. And that's when React just starts shoving in the JSX, right? Just shove it in there, and then it renders out as beautiful HTML for us. Yeah. Hey, DevD. Here, finally, what did I miss until now? We did a review of the basic concepts of React that we talked about last time. And now we're getting into the new stuff, talking about lists and arrays. So we're just getting started on the new stuff. Rascal says, JSX got so linked that it's not too uncommon to use it outside of React context as a literal EJS replacement via template engine. Yeah, I can definitely see that. Well, especially if you're just doing, if you're just building stateless components, right? If you're just building stateless components, it becomes pretty similar to what EJS can do, right? Hey, piece of shoot. Thank you for the follow, Edna. I use it oh wow, Humanoid says I use it for pretty much anything declarative, formatting, 3D rendering, even API routes. Wow, okay, so take it from Humanoid. You can use JSX for a lot of things. Thank you for sharing that, Humanoid. All right, so again, our HTML itself is really just a container div, and then we're hooking to that, and we're generating our list items using map, just a built-in array method. And we're taking that, we're finding where we're going to put it, and we're rendering inside of that HTML div. We're going to be rendering everything, and we just wrap our list items in a UL tag, and what that turns out to render as is our unordered list, looking just like a plain old set of HTML tags. So yeah, fairly straightforward, right? But I thought that would be a good reminder to tell us, okay, wait, how do we translate this stuff? How does this stuff hook into our HTML file? Okay, cool. So any questions there any questions on just the basic kind of React setup before we go on to more new concepts? So yeah, feel free to ask questions anytime, by the way. All right. Going over it once more. Yeah. So what we do is inside of our HTML, we really just have a single div, right? There's nothing here. We aren't writing any HTML. We're just writing a single div with an ID of root. And this is just giving our React an attachment point. So it knows where it's supposed to be dumping all the things it's rendering. So just where do React is like, hey, I've got all this stuff. Where do I put it? And we're like, put it in this div that's called root. And so the nice thing about that is that let's say I had a bunch of other HTML on this page and I just wanted to put my React in a certain spot. I can tell React exactly where to put this stuff by identifying the location that React should render this stuff. So I could have tons of tags above and below this, and React would ignore them. It'll just drop it in here. Yeah, we already declared root exactly. And so this is so components are pretty much like a bunch of reusable snippets. Yeah, I mean they can be. You can definitely make reusable snippets. Um, you can make a bunch of components and then call them multiple times. So let's say you have a button that does certain behaviors. So maybe here's a good example. So you know how when you're on a web page and you're filling out a form or you're choosing options on the page and they don't want you to continue until a certain point. That so a button might be grayed out and not work until certain conditions are met, until you've actually maybe like checked the box for the terms and conditions or something like that. Who knows? And so you could have it so all the buttons on your page are disabled until the user has performed a certain action. And an easy way to do that would be to create a reusable button component that you define yourself, and it would be it would be wrapped in it would be like basically just like it would look like just a custom HTML tag. You would call it just something like you know tag custom button tag, and you could call it in just that way, just that easy way, and reuse it as many times as you wanted. And I think on the let's see, I want to show an example. Components and props. Yeah, so when let's say we create a custom component called welcome, and what that does is it just says hello, and then you pass in a name as an argument, and it renders that name. So our function is called welcome. And now that we have this, we essentially have a reusable component that we can call as many times as we want. So for example, down here, we're calling welcome 3 times and passing in 3 different names. And so that becomes a reusable component that we can just reference over and over again. So that's a useful thing. And so components are so yes, they are reusable snippets, but the cool thing about these components too is that you can make them interdependent on each other. You can make them interdependent on each other. So think about the tic-tac-toe board. So if you were here for the last class, we did a tutorial where we made a tic-tac-toe board. And in that, we made it so that there was a parent, which was like the board, controlling all of the individual squares inside of the board. And so with the parent controlling all the individual squares, we could always tell immediately when there was a winner. And when there was a winner, we could shut off all of the child squares so that you couldn't click on them anymore. And we could sort of make decisions for all the child squares simultaneously if we needed to. So that can be another useful thing, is we can create these hierarchical relationships between our components so that your web page, so that independent elements on your web page can stay in sync with each other. And that could be useful, for say forms with multiple parts. Uh, yeah, just tons of different components that you can make interreliant on each other. So many application forms have React as something they want to work with. Thinking about making a React version of my $100 project in the next few weeks. Yeah, that'd be awesome. And I'm sure, like I say, I'm sure Leon will have some great templates and examples that we can use. And they even actually mentioned some great, some places you can get templates for forms in this documentation itself. And so we'll get there in just a minute. They even give you they even say, here's a great place to find some pre-built forms that you can just dump into your application. Rascal says, I'm going to be going over all the projects we've done and convert them to React just for the practice. That sounds awesome. Yeah, absolutely. I think React is super powerful, and it just builds on top of. It's just like the frosting on top of this nice cupcake that we've spent all this time baking, right? The frosting is what makes it look really good and be really tasty. And so I think that React is going to be that for us. Oh, thank you, Deep Fried Penguin. That's so nice. My goal is to always keep getting better and better, and keep making difficult concepts easier to understand. And it helps me understand while I'm explaining it to you. So it's a win for all of us, really. And I hope to keep doing this. All right. So we were talking about lists. Um, and so, okay. So now talking about, let's see, we did the list items. I'm gonna get back to where we were. Yeah, we were here. Okay. All right, so we saw how lists can be rendered. And now let's look at a basic list component. So if we recall that our vocab words, a component is essentially like a self-contained function or class, like a JavaScript function or class. It's self-contained in scope and function, right? Um, so usually you would render lists inside of a component. And so what we're going to do is transform that example into a component that accepts an array of numbers and outputs a list of elements. Okay, so instead of just hard coding an array, now we're going to transform it into a component or a function that accepts props or arguments and then outputs that as an array. And if you recall again, props are just an argument that gets passed to a function, right? It's just another way of calling it. So here we have a function which takes some props, and those props, we're just going to rename them to a variable called numbers. And then we're going to take those numbers, map them to list items, and then return an unordered list containing those list items. And so now they're showing how we can apply that. So we have an array with the numbers 1, 2, 3, 4, and 5. We create a link for where our React is going to put our output. And then we simply call the component, pass in our number array, and render it. And so if you noticed how this component looks, let me just, let's see this in here. I'm just going to grab this and drop it in CodePen real quick. Okay, so let's look at this. So notice how we call this component. If I take out the props, it'll be a little easier to see if I take out the props. If I take out the props, look at how this looks. It looks just like a regular old HTML tag, except it's actually the name of this component that we created. So it's important to remember we can call these components with a syntax that looks similar to HTML tags that we're familiar with, except it's actually a custom component that we've created. But the neat thing is that we can actually pass in the arguments to our function or our props inside the tag itself, and it's just like passing arguments to a function. Now, what's an easy way I can tell apart? So let's say I was just calling this. Let's say I was just calling this component with no props. Let's say it didn't have any props. I was calling this component. What's an easy way that I can tell immediately just by looking at this that it is a custom component and not a standard HTML tag? How can I tell the difference? This is a little. See if you remember this from last time. Pop quiz. Yeah, right. Exactly. Y'all were quick on that. Yep. It's the capital letters. The fact that we capitalize our custom components. And that's how we can immediately tell the difference between them and a standard built-in HTML tag for like a div or image or I don't know, anchor tag or something like that. Yeah, we've got our uppercase. Exactly. Duva Lane coming in there with the first time chat. Nice. Yeah. All these first time chatters just come in there. They always come in with the right answers. And I'm like, dang, y'all will just like waiting. And then you come in and you're like, I know this one. Yeah. So I love that. That's awesome. Good to have you here. Okay. So yeah, that's how we can tell the difference. And, obviously you can also tell if you're passing in a custom argument as well. That's a pretty easy way to tell. But yeah, so we can see when we do that, we pass in our array. We've passed in that array of numbers as a prop. Our component is expecting this prop. It assigns it to a variable. It maps those to list items. We return our unordered list, and we simply render that list inside of our div. So simple as that. And what's interesting is I didn't get an error. I was actually expecting to get an error on this, but I didn't, which is kind of fun. I wonder why. But anywho, when I ran it before, it says when you run this code, you will be given a warning that a key should be provided for list items. And yeah, a unique thing about React is that they expect us to use keys in lists. And a key is a special string attribute that you'll need to include when creating lists of elements. Now, for some reason, they don't tell you why right here, which is dumb. So I'm going to tell you why. And we actually went over this in the tutorial during the last stream too. So keys are important because they are unique identifiers. They're unique identifiers for the individual elements in our list. Now, where have we seen unique identifiers for a group of items before? Where do we know? How are we familiar with unique identifiers? Yeah, we've seen them in MongoDB, right? We've seen them in databases. Yeah, exactly. We've seen them in databases, and this is a pretty deep cut. But we also saw them a long time ago when we were looking at classes for starting out in JavaScript. But yeah, we're more recently we've seen them in MongoDB. And why are unique IDs important? Why do we care? Why are unique IDs important? How do we use them? And then I'm talking about in the MongoDB sense. You don't have to tell me in the React sense. Sorting, yeah, we can use them to sort. We can reference them, and then in the MongoDB sense, they give us a yeah, it helps find one, right? It's truly a unique identifier for that individual item in our group of items, right? Because I could have two people named Brian in a list, right? And so how would we know which Brian we're talking about unless we have a truly unique identifier that points to the correct Brian? And so in the React sense, remember that React is always looking for changes in order to know, what components it should update. What has changed? Has anything changed? What's changed? And so if the order of a list changes, if we, shuffle the order of a list at some point, and then React is trying to compare, it won't be able to do that if the order has changed. It's not smart enough. It's just a computer. If a human looking at a list could probably decipher a sorted list and that has changed and do the matching, draw the lines between the two lists. But the computer's not smart enough to do that. And so it needs something unique to compare between the two, even if the list order has changed. Hey, Burgles, welcome. React Dev on Twitch. Actually, I'm a SQL dev, but I'm learning React, and so that's what we're talking about today. We're going through the React docs, we're reviewing some concepts, and we're learning together. So you're welcome to stick around if you would like to. Thing one and thing two. Yeah. Thank you for the follow, Lord Rubbish. Yeah, and so that's why keys are important, because they are truly unique identifiers, and React can use that to compare list items together and see if anything has changed. And for some reason, I do not know why they don't tell you here at this point in the docs. They're like, yeah, keys are important, but forget about it. And I'm like, no. So thank you for the follow, Burgles. They do in the beta docs. Okay. Yeah. And I'm sure we will read those at some point. We were specifically assigned to read this version of the documentation for the course that we're all taking together, which is called 100 Devs! Leon in chat. But yeah, I'm sure we'll definitely get to those beta docs. I'm eager to read those. Okay, so in this case, we have our list, and we didn't assign a key, but we should. And so how we can do that is fairly simple. Again, we have our numbers that are passed in as props, and we do our map, but we can also set a key value inside of the list tag itself. So just inside of that opening list tag, we just say, hey, key equals whatever. And in this case, our key is simply going to be the number. So key equals number.toString. Now the key could vary, it just as long as it's something unique. So let's take a look at that. And now I'm just curious. I'm going to remove the key. I want to see it throw me that error. It's still not throwing the error. That's so weird. I swear it did. It used to. Now CodePen doesn't care, apparently. I don't know why it's not throwing the error. That's funky. But normally it would throw a big red error saying, hey, you forgot to assign some keys. You want to do that? And so you should. It's being nice to me, I guess. All right, but I'm going to put it back. But it is very simple to assign key values. Just key equals, and then you set your value inside of the curly braces. Athena says, oh, you've only had, okay, so Azrael says, I've only had an error when two items have the same ID. Okay, let's try that. Let's do this. So I just changed my value there. Nope, that didn't work. Oh, well. Just know that it will throw an error normally. And Athena asks, this might be getting ahead, but does React have a random key generator like MongoDB? No, not as far as I'm aware. No. And Humanoid says, no, it doesn't, but you can use, okay, so there's a method you could use to generate that key automatically. Yeah, I figured there would be. Yeah, you can make a function. Yeah. Okay, and so now they do talk about keys down here a little bit, but it's basically what I already said. Keys help React identify which items have changed, are added, or are removed. Keys should be given to the elements inside the array to give the elements a stable identity. I feel like my explanation was better. The best way to pick a key is to use a string that uniquely identifies a list item among its siblings. So most likely you would use IDs from your data as keys. Yeah, and so, I mean, generally you're going to already have some kind of a unique ID. If you're getting that data from a database, which most likely we are at this point, right? We're getting it from MongoDB. We're getting it from a, I don't know, a MySQL database or something like that. It's going to have some kind of a unique identifier already. And so we can just dump that in there as the key and good to go. Easy peasy lemon squeezy. And Count the Shells says, yeah, you might be able to get the unique IDs from MongoDB if you're getting a list, right? Yeah, we already have that, and we have used that already in some cases in our apps, right? To do to link things together, to link, for example, a post to a user, to a specific user, we would use the user's ID, the unique MongoDB identifier. And so that's really no different. We can just drop that in as our key. Yeah, and Humanoid says we're not going to generate it inside the map. Yeah, exactly. We should have it by the time we go to do that map. We should already have the key and then just apply it. Yep. Generally, yeah, it's gonna, but it's hopefully we should be able to get it from our database. If your data is good, if your data is good, you should have unique identifiers. Not saying all data is good, but you do what you can. And it says if you don't have stable IDs for rendered items, you may use the item index as a key as a last resort. So, yes, if your data is cruddy, you could use the index instead. But it says they don't recommend using indexes for keys if the order of the items may change, right? Because if your order changes, then you're going to have a mismatch between your index and your item. Yeah, exactly. It won't work if you sort, and which is kind of the point of using keys, right? You want to control for sorting. So, not a good idea. Just use the database ID. It's all good. And if you don't believe it, you can click on this link and read the in depth explanation. And there's also another link here for an in depth explanation about why keys are necessary. If you're still not sure, if you're still not sold on the concept of keys, I think at this point we probably are, given that we understand their importance in the database. But if you want to learn more, you can click here as well. All right, so extracting components with keys. So keys only make sense in the context of the surrounding array. Excuse me. If you extract a list item component, you should keep the key on the list item elements in the array rather than on the li element in the list item itself. Okay, so let's look at this. Okay, so here what they're doing is they are specifying the key value here inside of the list item, which is wrong. And they're saying that the key should have been specified here prior to referencing the list item component. Okay, so let's see how it looks when it's supposed to be done right. All right, so we have a function called list item, or a component called list item, which returns a list item value, a single list item value. Okay, so the whole purpose of this component is to return a single list item value. Fair enough, cool. All right. Now we have a function here. We have another component here, which references our list item component. So we're calling on the list item component right here. It's just like a function calling another function. That's all it's doing. We're saying component, but it's a function calling another function. Okay. We pass in some numbers and we do the map. And since we're referencing this component, we first declare the key and then pass in our props. And then what gets returned is our list items, and we drop them in an unordered list. Okay, so it's just saying if you're referencing this component, define the key here and define the props here at the same time. And at this point, don't worry about that too much. Let's just remember what keys are, why they matter, and I think we'll be good. Don't worry about all this stuff too much yet. And it just says a good rule of thumb is that the elements inside the map call all need keys. Okay, keys must only be unique among siblings. So keys used within arrays should be unique among their siblings, and that makes sense, right? If we think about like the documents inside of a database, inside of a collection, all of those are going to be unique from each other. Um, all of those document IDs or all of those object IDs are going to be unique from each other inside of our collection. However, they don't need to be globally unique. We can use the same keys when we produce two different arrays. Are props in React passed as an object or a variable? And so what I've seen so far is it's similar to say like it's similar to like an argument that is being passed into a function. So I could potentially have an object stored in a variable and pass that in as an argument to a function, right? As long as whatever the function is expecting, as long as I give it what it's expecting, it seems that it can handle it. And so we can do that when we pass things in when we pass like state down from a parent to a child. Um, our state might have multiple elements and might be have multiple properties, and but we can pass that state down as a single um, looking like a single argument into that function. So yes, that was a long answer, but I think Count the Shells summed it up better when they said you can pass all sorts of things through props, numbers, strings, arrays, and objects. Think about what you can do with a regular JavaScript function. Think about what you can do with a regular JavaScript function, and seems like you can do that with these React components. Yeah, and as Rascal reminded us, everything is an object, right? In JavaScript, everything is an object. And so when we pass them as arguments, all the key value and property value pairs become an object when receiving them as props. Yeah, and we can pass other functions as callbacks. Exactly. Yep. All right, so keys used within arrays should be unique among their siblings. However, they don't need to be globally unique. Okay, so in this case, they're given an example. We can use the same keys when we produce two different arrays. So in this case, we have a single component that looks like it produces a list using the key as the post ID, and then another where we are mapping a group of, so a whole list of posts, including the post ID and post content. So here we're showing just the post titles as a list. And then down here, we're listing all of the posts with their title and their content. And so essentially it's like two different, we're looping through the array twice, and both times we're using the post ID as a key. But we can do this because this list is self-contained, and this group of divs is self-contained. So it works. And we can see how that looks. So how this looks when we render it is we have a list of the post titles, hello world and installation. And then down here, we have another list of essentially the post itself as divs. And for both of these, we're using the post ID as the key. But since they're self-contained and separate from each other, we can actually do that. We don't have to worry about those keys conflicting in any way. Okay. So keys serve as a hint to React, but they don't get passed to your components. If you need the same value in your component, pass it explicitly. So they're saying if you want the key to itself be rendered, so the keys are like, it's kind of like in MongoDB, right? In MongoDB, when we create a document, we don't hard code the object ID. That's not something we care about. That's something that MongoDB does itself and MongoDB uses, but we don't hard code that. And so here it's kind of in the reverse. We set the key for React to use, but it doesn't render unless we explicitly tell it to. Or it doesn't get passed unless we explicitly tell it to. Again, let's not worry about that too much. Just know what keys are and know why they're important for React. All right, so embedding map in JSX. Oh, thank you for the follow, Doppler. In the examples above, we declared a separate list items variable and included it in our JSX. Okay, so what this list items, so remember this list item components, what it's doing is it's just creating, what it does is it takes in an input, it takes in a prop, it has a key, and it creates an individual li list item, right? And what we're doing is then we're mapping through our numbers array, passing each number in that array into our list item component, attaching it with a key. And what we get out of that is a li HTML tag with a key value and our number inside of it. So JSX allows us to embed any expression in curly braces. So instead, we could inline the map result. So instead of setting up all of our list items first as a variable called const list items and then having to pass that variable into our UL tags, instead we can make it more compact. We could make it more compact and just wrap everything inside of the UL tags. And this is just reminding us that what React allows us to do is essentially put any JavaScript expression inside of curly braces. So kind of like handlebars. I don't know if y'all remember handlebars from the Travis Media tutorial, but it kind of worked in a similar way. You could just put a bunch of stuff that wasn't HTML inside of curly braces, and it would take care of it just fine. It would execute that expression just fine. And so that's what React can do for us as well. We can take this map, wrap it in curly braces, and stick it inside of our UL. And what will come out is all of our list items inside of those UL tags. And it says sometimes this results in clearer code, but this style can also be abused. Like in JavaScript, it is up to you to decide whether it is worth extracting a variable for readability. Keep in mind that if the map body is too nested, it might be a good time to extract a component. Yeah, so it's basically that age-old argument. Do you want to be Code Wars style? Do you want to be a one-liner? Do you want to do a Code Wars style, or do you want to make it readable? So in the end, that's your decision, right? You choose how you want to write your code. Do you want to do 6 nested ternary operators, or do you want to do an if-else statement or a switch statement, right? So that's the choice that only you can make. Athena says neither. I want to do a nested if-else statement combined with a ternary just for maximum confusion. Yeah. Totally need to make this a one-liner arrow function. That's what I'm talking about for maximum confusion. Yeah. Thank you for the follow, Mr. Ether. Okay, well, I think this is a wonderful stopping point for a break. We've gone through the lists and keys section. And what we're going to do next is when we come back, we're going to talk about forms, our friend forms, that old HTML standby that's so very useful to us. We're going to learn how forms interact with React, and how we can kind of use React to take control of some of that form functionality for us. And then we'll talk about state, composition, which is very short. I think the lifting state up section is probably the most illuminating. It has some really good practice examples, so I hope we have time to get to it this evening. Count the Shell says, yeah, controlled components. Yeah, so our forms are going to be controlled components, which we'll talk about when we get back from the break. Also, when we get back from the break, I know Zena's not here, but I can't tease, like, showing you a foster kitten and then not show you a foster kitten. So I think I'll go ahead and oblige you all. I don't know that Zena is here. Zena, if you are here, please speak up. But either way, clickbait. Either way, I'm going to show you. I'm going to show you kitten because I can. All right, so let's put 5 minutes on the clock, and then when we come back, You'll get to see a cute kitten, and then we'll talk about forms. All right. 5 minute timer. All right. So go get up, stretch, get a drink, whatever you got to do. Or as Leon would call it, engagement. That's exactly what it is. Yes. All right. So go get up, stretch, get a drink, whatever you got to do. And then I'll see y'all back here in 5. Okay, folks, come on back. Come on back. We got about 40 seconds, 30 seconds left in the break. So grab your drink, pet your dog, and then come on back because I've got a little friend who wants to say hi to all of you. Let me see if y'all can hear her purring. Let me say hi. No, can't quite hear it. 10 seconds to the big reveal. All right, I'm going to go ahead and stop the timer. Oh, where's my camera? Hey. Okay, that's fine. We'll do this. Hang on, I got to turn it back on. All right. There we go. Here's a little friend. Yeah, so this little kiddo, she's got a very dirty face right now because she likes to stick her entire face into her food bowl when she eats. Um, but yes, this little friend who's purring quite a lot right now, she does not have a name yet. Amazingly, she does not have a name. She's loving this right now. What's the cat's tech stack? Right now, she really likes food. I think her tech stack is food. Well, if you want to name her, if you have just the best name in the world and you want to name her, I have a channel point reward for naming a foster kitten. So you are welcome to spend those points. Once you have the points, you can spend them and you can name a foster kitten. And I will use that name, and that is the name the shelter will use for them. Um, Although we got first time chatters coming in here to name a kitten. Yeah, I mean, those are great suggestions. I have a channel point reward specifically for that. So, yeah, great suggestions. If she doesn't get a name before she has to go back to the shelter, I'll definitely use, one of the names that people have supplied. But I want, folks to spend their channel points and get dibs on a name. There's some great suggestions though. Yeah, she's a real sweetie. Like I said, she loves to eat. Um, she loves cuddling. You can tell. I mean, she's like absolutely so happy and relaxed right now. She's so happy and relaxed. Her star of the evening is meow meow power. Yeah, and she's purring super loud. She's so happy right now. Yeah, this whole litter of foster kittens that I have right now, they are just the most cuddle bugs. Only one of them has been named. So one of the other kittens, Fig, has got a name. But the other two still need names. So she is, she's obviously black and white. And the other kitten is more of a traditional gray tabby, but still very cute. Um, she's actually falling asleep. Oh my gosh. She deserves all the cuddle forever. Yes, she absolutely does. Some kittens will just like claw. You pick them up and they just claw your hands, and they just claw you, bite you, that kind of thing. And I mean that's par for the course. They're cats, but these guys are just the cuddliest little buzzballs I've ever had. I think. Yeah, you falling asleep, aren't you? Yeah. Chat process on my OMG cat. Yeah. Yeah, so they definitely deserve names. So I do hope that someone, takes up the challenge to give them a name. Okay, well, I know as much as we would all love to look at cute kitties for the rest of the stream. Um, I think I think it is time to get back to work. Maybe I'm really enjoying just holding on to her. But I hit the spot. Yeah, any spot's the spot for her. She just loves being touched. Doesn't matter what it is. She needs someone to adopt her. Is what she needs. So once she gets old enough, she'll go back to the shelter. She'll get spayed and she'll be put up for adoption. I think any family would be lucky to have her. All right. So I am going to switch off the camera for just a moment, go put her back, and then we will get back to learning about forms in React. She seems chill. Yeah, she's super chill. She's like completely relaxed. She's just like she's utter jelly right now in my arms. All right. I'll be right back. Okay, and we are back. All right, welcome back to the real world, where we got to do code and stuff, and it's not just kittens. Gwen Saab says, "I want a kitten now." Well, definitely. I always like to recommend fostering if you're into that. Fostering, like I do, allows you to have cute kittens all year round. Um, and bonus points is they go back to the shelter and they get adopted and they become, somebody's forever cat. So that's what I love about fostering, and I highly recommend anybody who's interested in it. Reach out to your local shelter. They generally can give you all the supplies that you need. Um, and you don't got to worry about any of that stuff, and you just get cute kittens. So pretty much a win-win, I would say. Boo, reality sucks. Yeah, it does suck sometimes, but we do all we can to make it better, right? Transition effect is rad. Thinking about adding any other effects? I mean, I don't know. I guess I can. I didn't even know that these effects were built into Twitch Studio until like last week. So there might be some other effects in there somewhere. I do want to add a green screen effect to be behind my head, so that y'all don't got to see that useless background and you get more screen real estate. So I am working on that. Because that, yeah, I definitely want to add in some chroma key around my head. Mind rocking that sweater. Oh, thank you. I used to work for an e-commerce company that printed T-shirts, and so I got a lot of freebies, and this is one of them. This has got the Elon Musk the Tesla Roadster that he launched into space. It's got that on it, so pretty cool. Foster a dev. Yeah, there you go. Foster kitten, foster dev. I feel like 100 devs is like the ultimate like dev foster program. It's great. All right, so we just finished up talking about lists and keys. So let's go ahead and go on to forms. Okay, so as we know, HTML form elements are kind of special, right? So HTML forms are like a little self-contained unit in itself, right? So inside of a form, we can put various types of inputs, and the user can enter values, and then as soon as they click a button, essentially it packages up all of those inputs together into like a single unit, and it can send those somewhere. It can send them, most of the time what we do is we have it send those that form package, that object, up to our server, and then our server is just, it's ready made for our server just to do stuff with it, right? We could, send it up to a database, or send it to our controllers and do stuff with that. And so their forms in HTML are actually pretty powerful and can do a lot of things. So how do we pair those form elements with React? Thank you for the follow, Dev Team TV. Um, so HTML form elements work a bit differently than other DOM elements in React, because form elements naturally keep some internal state. So for example, this form in plain HTML accepts a single name. So it takes in a name, and it takes in a name as an input, and then um, when you click submit, it packages that up and sends it somewhere. So this form has the default HTML behavior of browsing to a new page when the user submits the form. If you want this behavior in React, it just works. But in most cases, it's convenient to have a JavaScript function that handles the submission of the form and has access to the data that the user has entered into the form. The standard way to achieve this is with a technique called controlled components. So form elements such as input, text area, and select typically maintain their own state and update it based on user input. So what they're talking about here is that, when I type something into an input box, it shows up and we can see that immediately. And then, what's in that input box changes depending on my keystrokes. So I make a backspace, it deletes a letter. I you know fill out one input box and then go to fill out another. That first input box stays populated. It maintains its own state. It updates that state when it needs to. and it remembers what's been entered, right? And so that's kind of unique behavior. It's keeping track of what we've done in the past and updating when changes are necessary. Thank you for the follow, Chuck. But in this case, what we're talking about here is making that into a controlled component. So maintaining the same behavior, but having React be the thing that controls that behavior instead of the HTML element itself saying React being like, no, I can do the same thing for you. I'm just gonna step in here and manage that for you. So in React, mutable state is typically kept in the state property of components and only updated with set state. So we can combine the built-in state and the React state by making the React state be the single source of truth. Thank you for the follow, Kuzo. Then the React component that renders a form also controls what happens in that form on subsequent user input. An input form element whose value is controlled by React in this way is called a controlled component. Okay, so what they're going to do here is rewrite that inbuilt form. So this form that takes in a name, and we're going to rewrite that inbuilt form as a controlled component and have it console log the name. And we're going to do this as a class component. So remember, there's two different ways we can write components. They can be written as functions, like as a standard JavaScript function, or we can write them as a class. And in this case, since we want to set state, we want to have a constructor. So this component is going to control its own state. And so in order to generate that state value, we want to have a constructor. And if we remember our basic JavaScript, essentially, with ES6, we have classes. And inside of those classes, we can have constructors, which help us build objects. And when we're talking about state constructors, we always need to have the line for super. That's just always going to be in our constructors. And then we set our state by saying this state equals, and then whatever our state is going to be. And we talked about this in the last stream too, but this is the first time we're really seeing it in this stream. So I wanted to pause on that for a moment. We saw that in our tic-tac-toe tutorial that we did. So all of the child components really were just sort of written as JavaScript functions. Like the individual squares, they didn't control their own state. That state was passed down to them. So they were just written as regular functions. But any controlling components that set state, we wrote as classes with constructors inside of them. So that's what we're doing here. So we're setting state, so we have our constructor. And so we're just doing a little bit of setup here. We're setting our state, and we are also setting up for our two sort of handlers here. So one we need to set up to handle change, and then the other we set up to handle submit, because that's what the form does by default, right? Anytime a user enters a keystroke, it updates. So like an input box will update itself to show what the user has just entered. So if I enter the letter A, the input box is going to update itself to show that I've entered the letter A. Or if I do a backspace, it's going to update itself to backup one. And then it also needs to be able to handle submission events. So if I click the submit button, that form is going to submit itself, right? And so we need to handle both of those events in React. And so what we're doing here is every time there is a change, essentially we reset our state to be whatever the current value is. So if I start out with a blank input box, which I should, we're going to start out with a state of empty string. And then each time I make a change, each time I enter a value in that input box, we want our state to update to whatever the current value is. And then as soon as I click submit, I want it to throw an alert, show the current value of the state, so whatever is in the input box, and then render And so we've set up our two handlers, and then finally we're going to actually render what that form looks like, and have those have our components ready to fire. So inside of our input box here, we set the value of the box as whatever the current state is. So in this case, it starts out as empty. Our first value is going to be empty. And then on change, we go to this handle change, set the state as we talked about before. And then on submit right here, we simply handle the submit as dictated here. So let's try this on CodePen. I think it'll be easier if we actually do it. All right. So inside of this form, let's see what happens as I start to type. So remember, we're rendering a form here, and by default, our value is currently an empty string. I can change this value though. So I can have the default value be something different. Yeah. So now by default, this form renders with a default value of hello, because my starting state is a value of hello. And that's what the form's interpreting as the default value. Now, as I make changes, oops, I shouldn't say that. There we go. As I make changes, it updates itself. The state changes, it updates itself. And so it behaves just like we would expect a normal input box to behave, even though it's fully controlled by React at this point. So let me type in hello and click the submit button. Now, as soon as I do, this on submit will fire. Whoops. On submit will fire. We'll handle the submit. We should get an alert that says a name was submitted along with the current state value. And I don't know if you can see that, but when I click submit, it says a name was submitted. Hello. So really, it's like so this is kind of a weird example, but are y'all familiar with there's that one Maxwell says hello. there's that one particular like fungus. So there's a fungus that can go in and like infect like insects and control them. And what it does is like it completely takes over all of the nervous system of the insect, and it controls them, and it makes them climb a blade of grass. And I forget why. I forget what the life cycle of this fungus is. Zombie bugs. Yeah, it basically turns them into a zombie. So the insect can still like move and stuff like that, but it's completely controlled. So it still has the same abilities, but it is no longer in control. The fungus is in control. And so that just reminds me of this: is that we're mimicking the same behavior that we would expect from this default HTML tag, but you wouldn't see anything just by looking at it. It looks the same, it behaves the same, but on the backside, it's all a fungus. It's all just React. So you wouldn't know by looking at it, but instead, what we have is a completely different way of performing these actions on the back. Cordyceps, that's it. Yeah, it's the cordyceps fungus. So I don't know. That's just how my brain works, and that's immediately what I thought of when I saw this. I was like, you can't tell. Like if I hide the JavaScript, you can't tell. But behind the scenes, it's all a fungus. Fungus React. Yep. So when you think of React, think of a fungus. It was React this whole time. Yeah. Or like the two astronauts, orbiting the Earth, one, pointing at the other. Like it was React this whole time. Always was. Yeah. So anyway, that's how we can create a controlled component using React. And since the value attribute is set on our form element, so we are setting the value here. We're constantly resetting the value of our input box as the current state. The displayed, that way React becomes the source of truth. And since handle change runs on every single keystroke, the displayed value simply updates while we type. So this handle change runs on every single keystroke. We're resetting the state on every keystroke. And so the state keeps changing, and then by default, the value changes for our input box, and so it looks no different from the user's perspective. So with a controlled component, again, the input's value is always driven by the current React state. While this means you have to type a bit more code, you can now pass the value to other UI elements too, or reset it from other handlers. So it allows for more control over these forms rather than being self-contained inside their own little form tags. We can now make this, we can now pass that value to other elements. We can share that state across multiple children, or like they say, or reset it from other handlers. Count the Shell says, but it is true. It blew my mind when I first started learning about it. You're not seeing the keystrokes. Exactly. You're not seeing the keystrokes at all. You're seeing the state. Yeah, which is wild, right? Leon's going to be so confused tomorrow. Why are y'all calling React a fungus? Yeah. That'll mess with him. Yep. Definitely reference that and see if he's like, what the heck? Okay. So let's look at some other, so we looked at how we can interact with inputs, but let's also look at the text area tag. So hopefully we've all at least seen text area by now, but you may not have. And so what text area is it's just a tag. Let's just see if we can pop this in to pop this in here. Yeah. So I just dropped it in just as a plain HTML tag, not as React. I just dropped this in as plain HTML to show you what a text area tag is if you're not familiar with it. And what makes text area tags different from input boxes is that you can resize them like this, and they have built-in scroll bars, and they basically allow you to write long form text like multiple paragraphs in a single text box. So unlike input forms, which are one line, text area allows you to have multiple lines of text. And I'm sure you've definitely seen this type of input on, say, maybe like a government website, or one of those utilitarian long form websites where they want you to put in a bunch of text. And so quick pro tip for those particular types of websites, if you didn't know already, you can resize this box to actually allow you to fit all of your text inside of the box without scrolling, in case you didn't know that. Okay, so that's what a text area is. But in React, text area uses a value attribute instead. So just like an input box, text area can now use a value attribute. This way, a form using a text area can be written very similarly to a form that uses a single line input box. And so basically, there's really no difference here. We're just setting a state, handling the change, and really just setting up this text area, this text area tag the same as we did a single line input. We set the value, which the value just becomes the current state, and telling it what to do on change. So every time the user types, we reset the value to the current state, and so it mirrors the user's keystrokes. So really just the same as the input boxes that we looked at before. And Count the Shells says, in HTML forms, usually all the info is collected on clicking submit. So you type, and then the info is collected on clicking submit. In React, with a controlled form, you're constantly updating the state with the on-change handler. Yeah, and that's another advantage. You're right. We don't have to wait until the user clicks submit to have what they're typing, right? Because we're constantly updating that state. And so, yeah, you could do things like make a button appear once the user has typed enough words. So once they've typed, I don't know, like a full, like 10 words, you could have certain buttons appear or certain options appear. And so that could be really useful. We could, for example, use it to filter, say, a list of items. No worries, New Horizons. React's coming along, normalizing all these input element APIs. Yeah, and it is kind of nice, right? Because if you're just using base HTML, input tags and text area tags behave differently from each other. They don't behave the same. But what React is doing is it's kind of like Rascal said, it's normalizing them so so that you can apply them in the same way, essentially. And it says, notice that this .state.value is initialized in the constructor so that the text area starts off with some text in it. Yeah, and I demonstrated that on the last example. You can set the state to have a default value. So please write an essay about your favorite DOM element. Write a love poem to your favorite HTML tag. Go. And so, yeah, you can set the state to have a default value, and then as the user types, that value will, of course, update itself. Maxwell says, so right now when you hit submit, that text just disappears. I think this is how Ticketmaster customer service works. Yeah. Yeah, they just have a bunch of forms that you hit submit and the forms aren't even attached to anything. The data doesn't go anywhere. It just disappears. Yeah. I'm sure that's right. Whoa, dude says, to div or not to div? That is the question. Man, I used to have that whole soliloquy memorized for no particular reason. Like, I didn't have to do it for school or anything. I just used to have it memorized. I don't have it anymore, but yeah. Don't ask me to quote it, but I used to know it. Okay, so let's talk about the select tag. So what does the select tag do? I'm sure we've all used it at some point, but it allows us to have a drop-down list. So let me just drop this in CodePen real quick. And let's see, not this one. Let's do, yeah, let's put it in this one with this other one. All right. So this is an example of a plain HTML tag with a drop-down list. I'm sure a lot of us have used it. Drop-down list. I like your enthusiasm, Chanpo. Yeah, so that's by default how a drop-down list behaves. It says, note that the coconut option is initially selected because of the selected attribute. And so with drop-down lists, with raw HTML tags, we can specify a value to be, what are you doing, buddy? Sorry, that's my dog. What are you doing? We can specify a value to be selected by default by just saying selected. All right. And so React, instead of using the selected attribute, uses a value attribute on the root select tag. So let's see how that works. This is more convenient in a controlled component because you only need to update it in one place. All right, so let's see what we're doing here. So very similar to the other input and text areas that we already saw. We set our, except instead of, for example, it's in our input, text input and text area fields, we were able to set a value that would appear in the text input box by default, right? Now for the select dropdown, we specify the value that we want to show up in that selection by default as our initial state. So value coconut is the first value that we want to show up in that dropdown before the user actually makes their selection. So default value is our default state. And everything else is the same here. Our handle change is the same. We set our state so it records every interaction. We handle our submit by saying an alert, saying your favorite flavor is, and then we actually render the form just as before. But the difference here is that instead of setting a default value here inside of the option list by saying selected, before in the default tags, we would say um, selected value coconut. Using React, we just simply declare all of the options without specifying one as the default, and we set the default value here in the base select tag. So it's just a small change, right? It's not that big of a deal. It's just a small change. Instead of setting it down here, we just set it up here inside of the opening select tag. So value this dot state dot value, and then on change. So this now looks very similar to the other two tags that we just looked at. It looks very similar to the input tag. It looks very similar to the text area tag. So like Rascal said, we're basically normalizing all of these sort of default form elements. We're normalizing them to look and behave the same way, which is actually nice. It takes a little getting used to, but it is nice to see that we can pretty much set up all of these form elements, all these basic form elements the same way now. And so yeah, we just set up all the options, have our submit, and there's our form. So let's try this. And yeah, we can see that the default value here is set to coconut. Whoops, because that is, why don't you scroll down? There we go. That is what we set our default state to be. And just like before, I can choose an option and then click submit. So which one should I choose? Out of these four, you don't get to pick anything else. I'm going to take a drink here real quick so y'all get a minute to decide. I got to hydrate. Ooh, we got some mango fans up in here. Lots of mango fans. Mango! Lime. Mango is winning so far. Nobody likes grapefruit or coconut. All right, I think mango wins. Ooh, visibly twitching, coming in with the first time chat. Combo breaker. Yeah, grapefruit. Who doesn't love mango? I gotta say, I do love me some mango, especially like a mango smoothie. I really like a mango smoothie. Yeah. All right, we'll go with mango for now. All right, we'll submit. Your favorite flavor is mango. And so just like expected, we got our alert. And what we pass into this alert is essentially just the current value, the current state value, which is the value that was selected, mango. Ta-da, cool beans. All right, so we're normalizing all these form elements to behave in the same way and to be controlled by React because we pass in the current state value as simply the value that's displayed inside that form element. So instead of the form controlling its own state, we're allowing React to control that state like a fungus. Just remember don't forget the fungus. Cordyceps is your friend. Was Cordyceps the like the fungus that took over the world in like The Last of Us? Was that the same thing? Because if so, then it's not your friend. Okay, and basically they're saying here what I just said. This makes it so that input type text, text area, and select now with React, they now all work very similarly. They accept a value attribute that you can use to implement a controlled component. And you can also pass an array into the value attribute, allowing you to select multiple options in a select tag. Oh, that's cool. So inside of a select tag, we can now say you can select more than one thing. So if we say select multiple equals true, we can allow for multiple values. Nice. And then they mentioned briefly here the file input tag, and we just kind of started seeing that. So if y'all remember in the binary upload boom code, we have a form that allows you to upload a file, like an image file or whatever file, from your computer, which we then store in Cloudinary. And that's a default tag. That's a default HTML tag. And we can just say, input type file, which allows you to do that. And basically, they're just saying because this value is read only, it's an uncontrolled component, and that's discussed later. So we're going to skip it. Cool. Visibly says, I love the mango, but grapefruit needed some love. Aw, thank you for thinking of the poor grapefruit. Yes. And folks are telling me that yes, cordyceps was the evil fungus in The Last of Us. The Last of Us show teaser looks promising. Yeah, there's going to be a series for that now. I'm kind of excited. I actually never played the game. I have it. I have it for PlayStation 4. I bought it from some dude at a sci-fi convention, like secondhand, but I still haven't played it. So maybe this will kick me to actually play it. The fungus isn't strong enough for file inputs. Yeah, it can't control the file inputs. Yeah. All right. So how do we? So far, all we've talked about is a form with a single input, right? One single input box. We set the default state, and we just pass that state constantly to the input as the value. So it constantly updates as the user types. But that's all well and good. But how do we handle multiple input boxes in a form? Because that's what we're going to see a lot, right? Most forms have multiple inputs. So how do we handle that? Yeah, I've definitely heard The Last of Us is really good, which is why I want to I want to be able to devote time to actually play it. So I haven't played it yet. That's mostly why I haven't played it yet. Okay, so how do we handle multiple inputs? When you need to handle multiple controlled input elements, you just add a name attribute to each element and let the handler function choose what to do based on the value of event.target.name. Okay, so let's see how that looks. All right, so here again, we have a constructor and we're setting our state. But now our state has two parts. So we have one part called is going, which is set to true. And then we have number of guests, which is set to 2 by default. Okay, and now our input change has been modified a little bit to basically say, okay, we have it's checking to see if the target type is the checkbox. And if it is, then it's going to check it. Okay. And then the second is const name equals target name. Okay, so let's see what this is actually doing here. I think I want to see this on CodePen first and get a better feel. All right. Okay, so we have a checkbox, which is called is going, and then we have a number of guests, which is 2. And so as I click this checkbox, it checks and unchecks, and as expected, I can change the number of guests. Okay, now there's no submit on this, which is interesting, but I guess it's a form with no submit. All right, so what is this doing here? Const target equals event.target. It's checking to see if this is the checkbox. And if it is, it's setting it to checked. Okay, okay, all right, I get it. So it looks like if it's checking to see if it's a checkbox, and if it is, it's performing the check action, and if it's not, it's actually just setting the value. So it's taking the keystrokes, because if it's not the checkbox, then it's going to be the input box. And here, it's setting the state depending on, okay, this is cool. So here, it's actually setting the state by taking the name of whichever box was being changed. So whether it was the checkbox, or whether it was the input box. So down here, we've actually set the name of these two to be to have a name called is going and a type of checkbox, or a name of number of guests with a type of number. No worries, Frazee. Yeah. And so, yeah, what this is doing, so here up here, it's saying, all right, const value equals, so checking to see the target type. All right, is it a checkbox? If it is, then target.checked, event.target.checked. If it's not, then it's treating it just like our previous input boxes and updating, based on whatever the user inputted. Nice. Okay. And visibly adds on to that, but saying because checkboxes don't have a value property, they have a checked property, which can be true or false. Yeah. So it's going to alternate that. If it's a checkbox, it's just going to alternate that checked property. And if it's not, then it's going to actually register the input just like we did before. But other controls have a value as previously noted with the select. Yeah, exactly. Nice. So with both, so it's what's interesting here too is that both of these are inputs, right? But we can just simply set the type, and that input box will change appearance depending on what type we set it as. So in this case, we can just say, hey, I want this to be a checkbox. So we just set the type as checkbox and it turns into a checkbox. Whereas with this, we can set the type as number and that turns into a special type of input box. Now you probably know this already, but if you didn't, you can set an input box to have a type. And so if it's typed text, it just allows for free, you can type whatever you want. But if you set it to number, it restricts it to only allow numerical inputs, and it puts in this little clicky counter. And that's just default behavior. It just puts in this little clicky counter for you, so you can click this to increment up or down. So yeah, we can dictate the behavior of the input box by specifying the type. Again, you probably knew that, but just calling it out in case you didn't. And again, as they said, we can control this. We can control which one we target by also giving them names. And it says, notice how we use the ES6 computed property name to update the state key corresponding to the given input name. And so they're just using a little trick here where we can pass in a property name value dynamically and set it here on the left and also set the value on the right. I'm a fan of clicky counter. Yeah, that's what it is. It's clicky and it's a counter, right? Yeah. Okay, and also too, they remind us that set state automatically merges a partial state into the current state. We only need to call it with the changed parts. Okay, so what does that mean? Well, remember that our state in this case has two parts, right? We have a flag for is going, which is this checkbox, and we also have a counter, which is keeping track of which is setting the number of guests. And at any given time, I'm only going to be changing one of these two things, right? I'm either going to be clicking the checkbox or I'm going to be making a change to the guest counter. I physically cannot do both at the same time. And so as I make a change to one of those things, that change will just be merged into the existing state and the other field will be left alone. So they're just saying changes are merged in. So it merges a partial state into the current state. We only need to call it with the part that we changed. Okay, so controlled input null value. Oh, and sorry, this was actually kind of this is probably the most complicated part that we talked about with forms. So does anybody have any questions on this before we go on? It took me a minute to remember what it was doing. mean, we didn't, and we. It's not like you have to like remember how to write this from scratch, right? A lot of this stuff is going to be copying and pasting. You're going to be grabbing components. Um, and it's more about just kind of conceptualizing, okay, conceptually knowing like, okay, this is what it's doing, this is how it's able to target those individual components, and pass that state. What are we drinking today? We are drinking, as usual, we are drinking only the lowest quality and cheapest black tea from Kroger. Yes. You know, I'm all about the high life, and today we are drinking the cheapest black tea that you can buy in bulk. Yes. It comes in a pack of like, I don't know, 100 pouches or whatever, and it's super cheap. Yum. Champo says, definitely save it in my code pen. I think that's a good idea, Champo. Yep. That way you can just pull it right out and copy and paste, Control C, Control V, my friend. Okay, so controlled input null value. Um, So specifying the value prop on a controlled component prevents the user from changing the input unless you desire so. If you've specified a value but the input is still editable, you may have accidentally set value to undefined or null. So the following code demonstrates this. The input is locked at first but becomes editable after a short delay. But when you speak of it that way, the T almost sounds premium. Hi, Allie Wolfie. Another wolf in the house. Nice. Good to have you. Plus one for the NASA mug. Oh, yeah. I love this mug. Mostly because of its volume. It holds a lot of tea. Uh, Beer.dev, I'm new over here. Why the classic React docs instead of the beta docs? Yeah, so this was actually assigned reading for us. So we are part of a free training course on that we're all enrolled in for web development. It's free. It takes you from zero to web dev on Twitch, using classes on Twitch. I'm a volunteer sort of helper with that course. And if you want to learn more, you can type exclamation point Leon in chat to learn more about it. But yeah, and so this was just part of our homework assignment to read these classic docs. And we will absolutely, I'm sure, get to the beta docs very soon. But we're starting out with the classics, getting the fundamentals, uh, and then working our way up to the newer expressions of React. Yeah, exactly, Ali Wolfie. You had the same question as Beard.dev. Yes, and I'm aware that there are newer docs, but we got to do our homework, right? And we will definitely get there. And it's good to learn, it's good to learn the older ways of doing things too, because you never know when you get hired. Um, if you're looking for a job when you get hired, your employer might have some legacy code out there that they might need you to refactor. And so you never know what you're going to see in the wild. No worries, Wolfie. Yeah. But yeah, if you want to learn how to become a web developer or just learn how to get a job, if you already have the skills and you just want, to get a job and don't want to have to pay 10 grand for a boot camp, if you just want to learn how to do it for free, um, definitely type Leon, exclamation point Leon in chat, and you can get some more info that way. Oh, thank you, X68. So they say, as a coder who interviews candidates, I can tell you she's right. Learn the basics. Most code is legacy code. Yes. And for those of you who are new to the stream, I am actually I'm a developer already. But I'm not a front end developer or a web developer. I'm a SQL developer. And I can also confirm what X68 said there. Most of the code that I encounter at work, most of the SQL that I encounter is legacy, and sometimes deliberately so. Sometimes it was stuff that was originally written, 20 years ago. But they deliberately keep, even though there might be newer ways of writing stuff, anytime we make changes to that code, we keep with the legacy format, we keep with the legacy syntax, just because it works that way and we don't change it. And that's more common than you might think, and across multiple languages and multiple roles. You sometimes legacy code is deliberately kept that way. Amazingly enough, as I've encountered when I tried to write something in the new way and then got smacked on the wrist. No, we don't do it that way. Write it the old way. Fine, okay. Ali Wolfie says, one more question. Why do you use Windows instead of Mac? That's what I've always used, and it's what my work uses too. Despite being a dev, I am firmly entrenched in Windows at this point. So, and also I like to game. So selfishly, I'm a gamer, and so Windows just works better for gaming. Let's not start a flame war of Apple versus Windows in the chat, please. There's a lot that could be said on both sides, but let's not get off track here. Ever played Among Us? Yes, I have. Yep. Use what you want, and that's it. Yeah, and that's what we say a lot, right? I say that all the time on this stream. Is it doesn't matter whether you're talking about your operating system, or you're talking about your templating engine, or you're talking about, how you write your JavaScript, right? It's about finding the right tools for the job and finding the right tools that you can use well and efficiently. And sometimes that might not be what other people use. Maybe it's down to the extensions that you've installed in VS Code, right? And but you got to use what works for you and what works well, and sometimes what your employer tells you you have to use, whether or not it works well for you. For example, my employer doesn't use GitHub. ah. So but I gotta use it because I gotta use what they use, because that's what they tell me, right? So it's important to be flexible and try to it's just important to be flexible, because sometimes your employer is going to make you be flexible. It's good to get in that habit. Oranges are the obvious superior choice versus apples. I gotta say, I prefer in fall I prefer a lovely fresh Granny Smith apple. I will say. That's when I use apples in the fall when they're fresh from the harvest. That's the best. Okay, so we were talking about controlled input null values. Yeah. Okay, so all they're talking about here is they're talking about forcing a default value for an input box. So let's open this in CodePen and see what they mean. So right here, they're specifying an input box with a value by default. So that value is high. However, what they're doing down here is then after 1 second, I think that's 1 second, right? 1,000 milliseconds? Yeah. Um, they're clearing out that input value, which will allow the user to actually put in their own inputs. I would eat Granny Smith year round. Yeah, I don't like it when they're not like super crisp though. That's the thing. They gotta be crisp. Otherwise, I'm not having it. Also, the question is, do you refrigerate your apples or do you eat them room temperature? That's another question. Do you keep them in the fridge and then like take them out and eat them cold, or do you put them on the counter and eat them room temperature? Very important question. All right, let's drop this into CodePen. I'm going to clear out what's already here and drop that in. Oh, I don't think it worked. Well, it's not working. But anyway, all this is doing is it's really just passing in something to it's really just passing in a default value in an input box. It would lock you from inputting anything because it's already passing in a default value. And then after a second, it would allow you to start typing because the value is because it clears out that value and makes it null. Oh man, room temp versus fridge. So Rassel says fridge, Chris says room temp, Piece of Shoot says frozen solid. Ooh. Uh, Taco Fed says they're getting hungry. Fridge, chilled fruit is superior. I tend to agree with you, Rianne. Yes. Yes. I gotta say, oh, Sirius says room temp too. Man, it's surprisingly more evenly divided than I thought it was going to be, honestly. My mother likes eating apples room temp as well, and I always thought she was nuts for that because they got to be straight out of the fridge for me. But I guess I'm it's more evenly divided than I thought. Wow. Okay. All right. Chris says some of us have some sensitive teeth. Okay, fair enough. Fair enough. Okay, I feel it. I feel it. Got you. Now we all need to define what room temp is. I'm talking about you set it out on the counter and wait until it equalizes to the kitchen temperature and then eat it. That's what I would define as room temp. Okay, so alternative to controlled components. It can sometimes be tedious to use controlled components because you need to write an event handler for every way your data can change and pipe all of that input through a React component. This can become particularly annoying when you're converting a pre-existing code base to React. Yeah, I can see that. Or integrating a React application with a non-React library. So think about if you already had a form, you would have to then code all your React components around that. In these situations, you might want to check out uncontrolled components, an alternative technique for implementing input forms. Okay, so we're not going to check that one out, but feel free to do so. If you're thinking about taking your existing project, with a bunch of forms and converting it to React, you might want to check this out and learn more about uncontrolled components as they suggest. Now, if feeling like writing these React forms from scratch is a little bit daunting, and I don't blame you, they actually give you a link right here to some fully fledged solutions for implementing React forms, and they suggest Formic. So we'll just take a quick look there. So Formic allows you to build forms in React and just kind of drag and drop them into your applications. And so I didn't really mess with this very much yet, but they have a lot of docs, they have a blog, they have a GitHub, so you can click around, experiment, generate your forms, and then drop them into your applications from here. So I would highly suggest don't do it from scratch. Find something pre-built like this and just dump them in. And it says, keeps track of a repetitive and annoying stuff, values, errors, visited fields, validation, submission, and it's just plain React state and props. That's always good. Yeah, and it's just formic.org. And you could that link is also in the documentation itself. So if you lose the link, you can just go back to the documentation and they call it out and they link directly to it. Yep. So definitely check that out rather than coding it from scratch. All right, so that's it for forms. And man, we're timing this really well. I'm kind of amazed. So time for another break. And we'll take a break for the next 5 minutes. And when we come back, what we'll talk about is lifting state up. And so what we mean by that is taking state out of individual components and literally lifting it up to a parent component which can control the state of all of its children simultaneously. So again, we saw that in the tic-tac-toe board, where first we lifted the state up from the individual squares on the board to the board itself, so the board could control the state of all of the squares inside of it. And then we actually lifted it up even higher to the game window itself, because eventually the game window needed to know which historical move had been clicked and then send that to the board to say, hey, board, here's what move we're on right now. And then the board was like, okay, I hear you. I'm going to tell my squares whether they should be X's or O's. And so, when we say lifting state up, that's what we mean is taking it from child to parent so that a parent can control all of its children directly and simultaneously. All right, so let's put 5 minutes on the clock. And we'll go ahead and get started. So go ahead, take a bathroom break, whatever you got to do, and I'll see you back here in 5 minutes. When we get back, we'll talk about lifting state up and wrap up the rest of this documentation. We're making good time. I'm proud of us. Go us. All right, folks, come on back, come on back. We got about a minute left, and we are almost done with this chapter. Yes, we've almost we've almost made it through the documentation, and I think my dog is happy about it because he just made the most like giant groan. I think my dog is done with the documentation. He doesn't want to hear me talk about it anymore. Whenever I'm streaming, he just falls asleep on the floor and seems so exasperated. Just like, geez, what are you doing, mom? All right. I heard a moo. No, that was not your stomach, and it was not a cow. It's my dog. He's done with the documentation. Oh, rascal. I'm gonna have to take away your VIP status for that one. Come on, man. Yeah, my dog is currently sprawled out on the hard floor. Like his life is so difficult, and then occasionally he just stretches and groans really loudly. Haskell says, worth it. All right, so now we actually get to do a bit of a more full-fledged example. So we're going to look at lifting state up, kind of similar to the way we did with the tic-tac-toe tutorial, except this time we're going to look at it in the context of everyone's favorite JavaScript application of JavaScript, which is a Fahrenheit to Celsius conversion app. I think we've all done this at some point, maybe more than once. It's a very common example of what you can do with JavaScript is building a Fahrenheit to Celsius conversion app. Except now we're going to build one that updates itself on the fly and allows you to put in either Fahrenheit or Celsius and converts it back and forth instantaneously. So that's what we're going to do. Talking about states. All right, so often several components need to reflect the same changing data. We recommend lifting the shared state up to their closest common ancestor. Let's see how this works in action. Yeah, so the way I think about this is thinking about there's a ton of websites out there where you can enter text like into a form, and then you can see that text kind of automatically populate inside of another element. So maybe inside of like a sample output or something like that. And so that's like the thing that came first to mind when I was thinking about shared state is you have a form which is obviously a controlled component. It's updating itself, right? The form is updating itself based on your keystrokes, and it's doing that via state. But it's also passing that state simultaneously to another output, which is showing your text with some kind of formatting, a new font or a different size, or inside of a different kind of a structure. And so that's kind of the first thing I thought of when I thought of what we can do by lifting state up to create sort of a simultaneous output into two different components. Okay, so what we're going to do here is create a temperature calculator that calculates whether water would boil at a given temperature. And so we'll start with a component called boiling verdict. It accepts the Celsius temperature as a prop and prints whether it is enough to boil the water. Okay, so we have a function, and it just says it's very simple. It just says if our Celsius temperature is greater than or equal to 100, the water would boil. Uh, if it's not, then return the water would not boil. All right, so I'm going to get a code pen going here. We'll try that, see if we can get this working. And I'm going to do this in side-by-side windows, I think. You get to see the meme again. Oh, now there's all the errors that we didn't see before. The console was hidden based on how I had the window structured. So, yes, all the errors were being thrown. You just couldn't see them. Cool. All right, so I'm going to grab this function. We'll drop it in. And all right, the next thing we're going to do is we're going to create a component called the calculator. It renders an input that lets you enter the temperature and keeps its value inside of our temperature state. Rascal 2 says, sounds like my kind of errors, the kind that you can't see, you mean? Yes, the best kind of errors, hidden ones. All right. So we'll have a calculator with our constructor that's setting a state of temperature, and by default, that temperature is going to be empty. And then as we type inside the box, it's going to update itself just like we did before, same as the other forms that we looked at. As we type, the state will update and it'll pass that value back into the input box. And so we're going to render, instead of a form, we're going to use a field set because we're being fancy, I guess. Have an input box, set the value as the state, and then on change, reflect the keystrokes and update the state. And then call the boiling verdict. So call that function that we wrote before, call boiling verdict, calculate the output temperature, and display that. So let's go ahead and pop this in. Actually, I'm gonna try it on CodePen here. All right. There. Come on, let me minimize you. Oh, field set. Okay, that's good to know. Thank you, Rascal. So field set, if we use field set, it gives us the neato border with this fancy looking interrupting text legend. Okay, so pro tip: if you want a good looking HTML tag without having to do any actual formatting, you can use field set to make it look funky like this. All right, thank you for that. But now for some reason I can't make this any smaller, so that's fun. All right, I might have to zoom out a little bit. All right, there we go. Okay. So here, again, we have our boiling verdict function or component. Yeah, and this title is from field set legend. Yep. And now we have our additional component, which sets our state, sets a default temperature, which is empty. Now, again, I could have this say something else. I could set this to be something else, and that would appear inside of our input box. But we'll leave it blank by default. And as we type, it reflects that change in the box. And then displays the output of the boiling verdict component, which is water would not boil or water would boil. So if I enter a temperature in Celsius, now I'm a heathen American person, so I use Fahrenheit. However, I do believe that water boils at 100 degrees Celsius. All the Europeans are laughing at me right now. But as soon as I type 101 into the box, the output from boiling verdict, that other component that we made, the output from boiling verdict changes because what we passed into boiling verdict as props, as our arguments, is literally the temperature from the box. So the current state, it passes that into boiling verdict. Every time the state changes, it passes it in and checks to see whether the water would boil or would not boil. So it's kind of cool. It's constantly passing that value in, constantly checking to see if this value should be updated. Now it's passing that in as props, as an argument, to check that. Okay, so that's how we're starting out. Now we're going to go ahead and add a second input because we want to make a converter that's going to allow us to put in either Fahrenheit for the Americans or Celsius for literally everyone else. But you know us Americans, we always, you always got to accommodate us, right? So we want a separate box that's going to allow us to put in our stupid Fahrenheit numbers also along with the Celsius values. Got to add a separate box for the Americans. All right, so let's add a second input. Our new requirement is that in addition to Celsius input, we provide a Fahrenheit input and that they are kept in sync. So that's the other thing about this is that if I type inside the Murica, if I type inside the Fahrenheit box, um, I want the Celsius temperature to update, and vice versa. If I type in Celsius, I want the Fahrenheit temperature to update. We want to stay in sync so that things don't get confused. I like how so my viewer count jumped up to almost 100 there for a minute, and then when I started ragging on the Fahrenheit system, it went down to 75. I got a lot of folks out there in Twitch land that are apparently big fans of Fahrenheit. I'm sorry if I offended anybody. People like the Fahrenheit system, I guess. Sorry. All right. So let's add that second input. So we can start by extracting a temperature input component from our calculator, and we'll add a new scale prop to it that can either be C or F. Okay, so we're going to essentially first create an object called scale names, and we're going to set those values as C or F. We're cracking the controversial jokes out here. Yeah. You know me, super edgy. Edgiest streamer on Twitch. Imagine doing all this manually. Yeah, that's a good point, Rascal. So imagine trying to do this manually with what we knew before React. Two input event listeners, both having to update the other input and update the boiling text. Yeah, you have to do a lot of crossing over there, right? You have to send things, you'd have to send things up. You'd have to do some calculations, pass them back down. Yeah, that's really difficult. And so what we're doing here is just simplifying this into kind of all in one React, right? Um, okay, so we're going to set up scale names, and we'll add that in. Okay, and we're going to make a change to our calculator. So start by extracting temperature input component from calculator. All right. And we'll add a new scale prop to it that can either be C or F. Okay, so we have temperature input now. And what that's doing is it's setting a default temperature state. So this is what's actually going to handle this is what's going to actually handle the inputs. Okay. And we can now change the calculator to render two separate temperature inputs. All right, so I'm going to add this in. I wish I could make this smaller. I don't know why this is not letting me shrink it. Why are you like this? Let me see if I can fork it. Hang on. Nope, still not letting me do it. I don't want to have to keep scrolling. Hmm. One second. Let me just mess with this a little bit. There we go. Okay. I just had to make it a little smaller. That's better. Now that should let me. Okay, there we go. Now I can change it. Perfect. Okay. Fixed. Yay. We stand on the shoulders of giants. Yes, we do indeed. That's the nice thing about programming is that we don't have to be the giants. We can just stand on their shoulders. All right, that looks a lot better. Okay, perfect. Essentially, I zoomed in too far and it was trying to do like a mobile view, which is garbage. So, yeah. All right. So I've got my scale names here, and we're going to grab this temperature input. And drop that in, which I actually already did. Perfect. Okay. And then we're going to change the calculator to really just render two versions of the temperature input. So we'll take a look at this in just a second and see what it's doing. Let's see. There we go. Okay, so now what we see is instead of a single input box, we now have two input boxes, one for Celsius, one for Fahrenheit. And let's see how we got that. So our calculator is now just rendering two different versions of the temperature input component. And we talked about that a little bit earlier, right? We talked about reusability. And this is an example of that. We have a component called temperature input, and here we're reusing it twice, except we're just passing in different values for the props. And when we do that, what we get back is two different legends here, one for Celsius, one for Fahrenheit. And it should do two different, it should do the appropriate conversion. So it should do for Celsius, it should do Celsius. And it should do, it will do for Fahrenheit, it will do Fahrenheit. But it says we have two inputs now, but when you enter the temperature in one of them, the other doesn't update. This contradicts our requirement. We want to keep them in sync. We also can't display the boiling verdict from calculator. The calculator doesn't know the current temperature because it is hidden inside of temperature input. Okay, so let's look at temperature input a little bit. So we have a constructor here, and we're setting a default temperature. We're handling the change just like we did before. Every time they type, it updates the box. And we're rendering the temperature. We're setting the temperature and the scale as variables, and what we return is whatever the scale name is and handling the change for whatever the temperature value is. Okay, so the scale should be what we're passing in. Yeah, scale names, Celsius and Fahrenheit. So when we pass in scale C, when we call temperature input and pass in scale C, it recognizes that as Celsius. Because scale names, this object here, defines C as Celsius and F as Fahrenheit. So we say scale names and using object notation here, call the scale value. So we're doing a lot of things simultaneously there, but essentially what it's doing is we call, inside the calculator, we call temperature input, pass in the scale value that we want, and then the temperature input component references our scale names object here and knows that if we pass in C, we want Celsius, and F, we want Fahrenheit. Did they spell Fahrenheit right? Yeah, that's right. Yeah, it looks weird. It always looks weird. Okay. So we have the way it's supposed to look, but it's not, these two boxes are not working together. They're independent of each other, and they don't know, the left hand doesn't know what the right hand is doing. They aren't talking to each other because we're calling them independently. Right now, temperature input sets its own state internally, right? Temperature input sets its own state internally, independently for both of those invocations of this component. So this component sets its own state, and this component sets its own state. Now, we saw that in our tic-tac-toe tutorial that we did, right? We saw that in the tic-tac-toe tutorial. Originally, each of the individual squares in the grid was setting its own state. They didn't talk to each other. And so what we did there is we moved the state up originally into the board. So the board controlled all of the squares and told them whether they should be X or O. And so that's what we're going to do here is we're going to take the state out of these individual temperature input components and move that state up into a parent so these two can talk to each other. Thank you for the follow, Dinu. All right, so let's write a conversion function. I think we all ought to have this memorized by now. We've done it enough. This is like a staple of JavaScript is writing a conversion function. But luckily, they do tell us what it is here. So we have two conversion functions, and these two functions convert numbers, and we'll write another function that takes a string temperature and a converter function as arguments and returns a string. We'll use it to calculate the value of one input based on the other input. It returns an empty string on an invalid temperature and keeps the output rounded to the third decimal place. So what this next function is doing is it's taking in a temperature, making sure it's a number, and then if it is a number, it's passing it through our conversion and rounding it and turning it into a string. And so what we saw before is that both temperature input components currently independently keep their values in the local state. So as we said before, each of these two components here set their own state, so they can't talk to each other. Beer.dev, go ahead and ask your question, and I might not answer it right now, but go ahead and ask, and I will answer it. So yeah, go ahead and ask. All right, so let's lift that state up. We want these two inputs to be in sync with each other. When we update the Celsius input, the Fahrenheit input should reflect the converted temperature and vice versa. In React, sharing state is accomplished by moving it up to the closest common ancestor, I like to say parent, of the components that need it. This is called lifting state up. We will remove the local state from temperature input and move it up to the calculator, which holds both of these temperature input calls. Move it into the calculator instead. If the calculator owns the shared state, it becomes the source of truth for the current temperature in both inputs. It can instruct them both to have values that are consistent with each other. Since the props of both temperature input components are coming from the same parent calculator component, the two inputs will always be in sync, just like our tic-tac-toe board. Let's see how this works. Okay, so first we're going to replace this.state.temperature with this.props.temperature in the temperature input component. Okay, so why do we think we're doing that? Why are we going to replace this.state.temperature with this.props.temperature? Going to testing your vocab knowledge real quick of what we learned so far about React. Why do we think we're doing that? Why are we replacing this.state with this.props? Any guesses? Now I'm going to watch my viewer count drop by 25. People bail. What do we think? Taco Fed says argument. Prop is the argument being passed through. Now Jeff's dropped in. What was the question? Yeah. So what we're doing is we're working inside of a little React thing here, and we are taking, we have a component that currently sets its own state, and we are lifting that state up to the parent component. And so one of the things we're doing is we're replacing this.state.temperature with this.props.temperature. And so my question is, when we do that, why are we doing that? Why are we changing it from this.state to this.props? Yeah, exactly. So what folks have said so far is spot on. So instead of relying on this its own state that's being set internally, we're changing it to this dot props because now that information is going to be passed into it from its parent as props, as an argument instead, right? Yeah, as piece of shoot says, you'll pass it down as a prop because you are lifting the state up to a parent. So instead of making its own decisions, it's like so we're basically what we're doing is we're sending our component back to live with their parents for a while because they weren't making good decisions. And so they got to go live with their parents for a while, and their parents are going to kind of take over the decision making for a little bit. And all of its decisions are going to be passed down to it from the parent as props now, instead of it being able to make its own decisions. Sometimes you got to do that with a component that is not acting right. You got to send it home to their parents. Okay, so now that temperature is coming from the parent as a prop, temperature input has no control over it. It's coming in, we can't change it. It's coming from its parent. In React, this is solved by making a component controlled. Um, just like the DOM input accepts both a value and an on-change prop, so can the custom temperature input accept both temperature and on-temperature change props from its parent calculator. So all they're saying here is that you can pass multiple props from a parent to a child. When temperature input wants to update its temperature, it just calls on temperature change. So not only are we telling it what values to set, we're also telling it what to do when a change is made. And I'm not making any changes to what's over here in CodePen yet. Um, we'll take a look at this in fullness. I think it's easier to do, just to look at how the state looks once it's been moved. Okay, so let's recap our changes to temperature input. We've removed the local state, and instead of reading this dot state dot temperature, we now read this dot props dot temperature. So instead of resetting the state when we want to make a change, we now call this dot props on temperature change, which is provided from the parent. So instead of, again, what we do when we move state up is we take all of the thinking, we take all of the logic, all the thinking away from this particular component, and just expect the parent to provide the what they should be like what they should do when something happens. That relying on the parent for what happens when changes are made. Oh, thank you for the 2 bits, Anonymous. I appreciate it. Thank you for the cheer. Okay, so on temperature input, we're getting props and handling the change. So now we have to change our calculator component, which is right now just a render. We need to move the state up into that calculator component. Hey, Hype Fox, welcome to the stream. So the calculator now is going to need to set the state for the temperature input components inside of it. For those 2 children, it now needs to make the decisions. It needs to set the state. It needs to handle the changes and control what those 2 children are doing. Thank you for the follow, Lawbrat. Thank you. Lowbrat? Lawbrat? Yeah. Okay, cool name. Now let's go to the calculator component. We will store the current input's temperature and scale in its local state. This is the state we lifted up from the input. So that each of the input components used to keep track of that independently. And now we're going to keep track of it in just one place inside of this calculator component itself. It will serve as the source of truth for both of them. It is the minimum representation of all the data we need in order to render both inputs. And so an advantage of this is that now, instead of keeping track of two separate states in two separate places, we're now just keeping track of it in one single place. And so if we want to make changes to it, it should be easier to do. We're consolidating things. So if we enter 37 into the Celsius input, the state of the calculator component will be temperature 37, scale C. We're telling it what scale and what temperature. If we later edit the Fahrenheit field to be 212, the state of the calculator will be temperature 212, scale Fahrenheit. So the scale will change and the temperature value will change. We could have stored the value of both inputs, but it turns out to be unnecessary. It's enough to store the value of the most recently changed input and the scale that it represents. We can then infer the value of the other input based on the current temperature and scale alone. The inputs stay in sync because their values are computed from the same state. So we just pass the state down. We just pass the state down, and it keeps both of these two input boxes in sync. All right, so it's doing a lot here. So I'm going to open this in CodePen, and we'll just look at it as is here. All right, so let's review. We're setting our scale names, C for Celsius, F for Fahrenheit. We're doing our conversion. This is just a basic conversion function that we've done a million times. Converting Fahrenheit to Celsius and Celsius to Fahrenheit. We'll just reference those later. And then we have the function that's actually doing the conversion. It checks to see if it's a number, and if it is, it does the appropriate conversion and returns a rounded value. And then we have our boiling verdict, which determines whether or not the water would boil and returns a text value if the Celsius value is greater than or equal to 100 or not. And now we get into the meat of it. So temperature input, temperature input is now not setting any state. It's not setting any state at all. All it's doing is handling changes and keeping track of entries, and then rendering whatever it gets as props from its parent. So it sets the temperature. Basically, it sets whatever it sets the value in the input box based on the props it gets from its parents, and it sets the scale as Celsius or Fahrenheit, depending on the props that it gets from its parents. So it's not doing any thinking here. It's not setting any state. It's just getting prompts from the parent. Now the calculator is now doing all the work. It's setting the state, temperature, starting at an empty string, and the scale as Celsius. And it's handling the changes for both Celsius and Fahrenheit. And when it renders, it's actually also calling the conversion function. So by the time that value gets passed down to the children, to those temperature inputs, all the data is already there. It's immutable. It's not going to change. It's just getting passed down to the children, and the children just take it and be like, okay, yep, I'm going to render this for you. They don't do any of the thinking. All the thinking is now done at the parent level, setting the state, doing the conversions, doing the logic, and passing it down to the children and keeping them in sync that way. So it's setting the scale, Celsius to Fahrenheit, setting the temperature, doing the conversion, and then returning a div containing two temperature input fields, passing in the props, passing in the scale, passing in the temperature, and telling it what to do if that temperature changes. Same here, passing in the scale, passing in the temperature, telling it what to do on a temperature change. And then finally, calling the boiling verdict component to say, will the water boil? Will it not? So let's see how that works then. So if I enter in 0 Celsius, as expected, that's 32 degrees Fahrenheit. Now I'm going to change the Fahrenheit value to be, is it 212? Yeah, 212 is 100 in Celsius, and so it works both ways. Now it's keeping both of those values in sync. It's registering the change, it's changing the state, and it's telling both of the children exactly what they should do when that state changes. And it's also calling the boiling verdict as well. So this is a lot, but I would highly suggest. That's pretty cool. I know, right? It is cool. Yeah. So there's a lot here, right? This was a lot that we just went over. I would say it's more important right now just to grasp the general concept. Like, why did we do this? Why did we take the state from the individual components? And why did we lift it up to the parent? Well, so it could keep the children in sync. And in general, how does that work? In general, how does that work? The parent sets the state, and it passes that state down to the children as props. So the children don't have to do any thinking. They just basically render whatever they're given, right? They don't make the decisions. The parent makes the decisions for both of the children simultaneously and passes those down to the children so that they update simultaneously and they stay in sync. But I would suggest taking a look at this in depth as and studying more about what this is doing and how these components are interacting, because I think this is a really nice little example um, of changing state, lifting state up, and keeping components in sync. Pass the link? Yeah, of course. This is a link directly to this chapter, but if you've just joined me now, I would suggest reading through the rest of the chapter as well before looking at this. So I want to finish this example, and then I see there's some stuff being posted in chat. I will catch up with that. I just want to finish this with this last summary here. So it says, no matter which input you edit, um, the, the temperature state and the scale in the calculator get updated. One of the inputs gets the value as is, so any user input is preserved, and the other input value is always recalculated based on it. So let's recap what happens when you edit an input. React calls the function specified as onChange on the DOM input. In our case, this is the handle change method on the temperature input component. All right, so handle change is called whenever you edit an input. So type a keystroke or something like that. All right, so it looks for a prop passed in called onTemperatureChange. So the handle change method in the temperature input component calls this .props.onTemperatureChange with the new desired value. And its props, including onTemperatureChange, were provided by its parent component, the calculator. So the calculator provides this for the child to use. When it previously rendered, the calculator had specified that onTemperatureChange is so it's basically saying, this is confusing the way it's written, but it's basically saying when it rendered these two input boxes, let's look at that. When it rendered those two input boxes, it said onTemperatureChange for the Celsius box is handle Celsius change, and onTemperatureChange for the Fahrenheit box is handle Fahrenheit change. So they do two different things depending on whether it's a Celsius or a Fahrenheit box. Because Celsius change sets the state to scale C and then the temperature value, and Fahrenheit change sets the state to scale F and the temperature value. So either of these two calculator methods gets called depending on which input we edited. Inside these methods, the calculator component asks React to re-render itself by calling set state with the new input value and the current scale. So whatever change I make, so as soon as I make a Celsius change here, the scale gets changed to C and the temperature gets passed through. React calls the calculator component's render method to learn what the UI should look like. The value of both inputs are recomputed based on the current temperature and the active scale. The temperature conversion is performed here. So the rendering is redone. When a change is made, the rendering is redone and the conversion is redone. If scale is Fahrenheit, like for example, if the scale, so if I make a change to Fahrenheit, the scale gets set to F. And so when it's re-rendered, whatever value I entered in the Fahrenheit box is converted to Celsius and passed in as that value. And the reverse is done if I enter Celsius. So React calls the render methods of the individual temperature input components with their new props, and it learns what the UI should look like. And then finally, it also calls the boiling verdict component, passing the temperature in Celsius as its props. And then finally, the DOM actually updates. React updates the DOM with the boiling verdict and to match the desired input values. The input we just edited receives its current value, and the other input is updated to the temperature after conversion. Every update goes through the same steps, so the inputs stay in sync. So there's a lot of steps happening here, but what's amazing is that they happen pretty much instantaneously, right? We don't notice any delay, which shows how cool and fast this is. I would highly suggest taking a look at this in your own time and walking through each of these steps, looking at the finished code, walking through each of these steps, and trying to understand what it's doing and how it works. I think it's somewhat click. Hey, that's awesome, Pierogi. Yeah, like I said, that's really more than we can ask for at this point. Um, it's great if it clicks, but if it doesn't, as long as you can recognize some of these vocab words and conceptually understand why we might want to take state and raise it up to a parent, I mean, that's awesome. If you can understand that at this point, that's awesome. Um, so, lessons learned. There should be a single source of truth for any data that changes in a React application. Usually the state is first added to the component that needs it. Then if you find that other components need it, so we might have started out with a single box, but then we said, hey, I want to add a Fahrenheit box too for those Americans. At that point, you could say, well, I'm duplicating the state here. So why don't I raise it up to the parent and keep both of these boxes in sync? It takes less work to find and isolate bugs. You can implement custom logic to reject or transform user input. Just giving some advantages here. If something can be derived from props or state, it probably shouldn't be in the state. For example, instead of storing both Celsius value and Fahrenheit value, we store just the last edited temperature and the scale. The value of the other input can always be calculated from these in the render method. And you can also use the React developer tools to inspect your props and move up the tree until you find the component responsible for updating the state. And during the last stream, we mentioned about installing React developer tools. You can see how to do that in, I think it's item 3 here in the documentation. They tell you how to install those developer tools. Okay. Host state in the cloud, problem solved. Okay, so we're done with this section. Let me take a quick scroll back through chat here. I just didn't want to lose the flow there of what we were talking about. All right, so beard.dev asked a SQL question. So let's look at that. We have 2 or 3 tables with millions of rows. Okay, not unusual. The problem is we need statistics based on those tables. You think that implementing meta tables, when I say meta tables, I think of tables that hold general data per day or month and other fields is a good workaround. Let's say I will record the amount of clicks. So I will either create a new row in the meta table for the current day or increment with +1 if another click happened today. Okay, let me read this again. 2 or 3 tables with millions of rows. We need statistics based on those tables. Okay. I think that implementing meta tables, well, general data per day month is a good workaround. I mean, you could you could do meta tables. Let's say we call the number of clicks. You, I'm a little confused as to how the number of clicks relates to the data in your tables. Or are you talking about that your 80 million row table is recording individual clicks, and then you want to summarize those into like a count in your meta table? Is that what you're talking about? Okay, and I mean, if it sounds like if you're trying to summarize this in meta tables, um, it almost sounds like you are maybe trying to summarize this data for like executives or something like that. Trying to make like visualizations based on this, maybe. Um, there's are some pretty good visualization tools for that as well. For example, like Tableau is pretty good at doing um, summarizing data and doing visualizations. So you might think about that as well. I mean, yeah, but you can summarize those things in meta tables. They may not be as flexible as a visualization tool, though, to allow you to actually like so like hard coding those summarizations inside of like a meta table um, might not be as flexible and able to be sliced and diced as keeping the data in its current form and then using some kind of visualizer on top of that that could allow you to kind of summarize and slice that data on the fly, especially if you aren't entirely sure exactly what kind of summarizations you want, um, instead of like hard coding those into a table. I don't know. Just a thought. I prefer that when you can kind of slice and dice the data dynamically, um, whether that's through pure SQL or using a visualizer. It's for our users. They need to see the amount of clicks and the amount of orders they generate. Oh, a visualizer might be great then. Something like Tableau, if you can swing it. Especially if the metrics change. Um, especially if at any point you want to slice the data in a different way. Just my 2 cents. But I mean, yeah, you could do some if you could hard code some kind of summary table or something like that captures the um, that captures the amount of clicks per day and has the rows by date or something like that, and has various metrics by date. Yeah, you could do that. You might do you can maybe do like a view instead of a table. A view on top of using a view instead of a table might be a little bit easier to update. But I don't know exactly what your output is like for your users. But if you are trying to show data to users directly, um, it has to be a table. I would love to not have. Well, can you at least do a view instead? Could you write a view? I love that. It has to be a table. I would love to not have a table. We've all had that feeling. But yeah, if it has to be just inside of inside of a table looking format, maybe you could do a view instead. Yeah. Okay, so catching up on the rest of the chat here. Um, Ivan asked, "Hey, Mayan, long time no see. Off-topic question: Do you have any plans on what you'll be streaming once the cohort ends?" I'm going to keep streaming this kind of content. I don't plan to change. I mean, at least the current. I want to see where Leon is going after the cohort ends. I do want to stay in sync with the kind of things that he's doing, whatever that might be. If he has no plans to start another cohort, I probably will kind of start over. I didn't really start streaming at this. I didn't start streaming until 3 months into 100 devs, and so there's a lot of content at the beginning that I missed that I did not talk about. And for a while, I was not streaming on Twitch. I was streaming on just on Discord. And so I feel like there's room for improvement on some of the early content. So I think I'll probably start over and cover some beginning topics again for the catch up crew or people who are just starting out. Um, that's just my current thought. We'll see how that goes. It just depends on where Leon goes from here. Back in the day on Discord, yeah. So yeah, it depends on where Leon goes. I guess he has talked about potentially like licensing his curriculum out, maybe. And so I would be up for that. I would, sign up for that and to teach his curriculum. And so we'll see where he goes with it. Start my own boot camp. If I did, it would be free. I wouldn't charge for it. 100 wolves. Chris Capella mentioned the new React decks. Yes, we will absolutely get there 100%. We were assigned to read these older docs first. And I do believe we'll probably get to the new ones here pretty soon. Thank you for the follow, Nisfornides. So fun seeing it glow blue. Yeah. So if you've ever done, y'all should do that. Check out random websites. A lot of them do use React, and if they have components that update themselves, you'll see in the dev tools, you'll see those components glowing, flashing as they update. It's pretty cool. You'll see that a lot on more complex websites. They're using React, and those individual components will flash as they update. It's fun to watch, like little Christmas lights. Rascal says these GIFs are a bit outdated. The React dev tools are much more powerful than shown here. From knowing why something is re-rendered, inspecting all the things, the cool visual highlighting. Yeah. Migrated 2 minutes, 30-second query. Statistics based on clicks, orders, grouped by country, and other fields. From MySQL to approximately 20 seconds on Postgres. Queries are happening on the raw tables, and we need it to happen faster. Yeah, that's a challenge when you're trying to reduce your query time. I wonder if you could do any kind of like pre-grouping. So you could have like intermediate tables maybe that are doing some of those groupings first. So I would say maybe like so that's again where I keep bringing up views because views can be helpful in that way. So having like an intermediate view and then that does some of that grouping beforehand before you actually do the and then having a building a table off of that and then so having some pre-grouping done and then querying off of the off of a table that has now some pre-grouping done for you beforehand so that you don't have to do it all within the individual queries that you're running. Yeah, that's why I think you need some kind of an intermediate helper that's going to do some of that pre-work for you before you run the final query. And then my only other suggestion is I don't know what kind of indexing you have. I don't know if indexing is appropriate for your situation. That would be might be my other suggestion is depending on how you use it. Sometimes indexing can be helpful, but I don't know your current situation. Uh, LXS says, is it safe to use conditional rendering for admin or login like they do on the beta page? I don't know that I can answer that one. Maybe somebody else can. And Rascal coming in clutch saying, yes, conditional rendering is super common and pretty safe most of the time, though of course the backend should at the end of the day protect the admin routes and such accordingly. Yes. So you still need to do things like protecting your routes. Yep. We have indexes on your Postgres. Okay, good. That's a great start. You have two options to bring to the table. Yeah, no worries. And I'm like, I mean, I'm not a super expert, but at like you know optimization. But those are the things that I think of first when I think about how to make things run a little bit faster. And like you say, bearded dev, those are massive tables. I mean, 80 million rows ain't nothing to shake a stick at. And it also depends on the content too, right? Like how, it depends on the data that you have in those tables as well. You could also think about, is there any way you could, are there any superfluous columns that you could remove? Maybe that aren't you could also think about, making sure that your tables are as slim as possible for just the type of queries that you are running. For that click counter, are you just running it on, you know, like, does it just have like the date and the number of clicks and like the country? Like only the fields that you're filtering on should be the ones that you're querying on in that case, um, making sure that you're truly as slim as possible when you're with the data that you're trying to query against. Um, Lots of things to think about. Hopefully that helps a little. We'll see. I also thought about, yeah. So I think we're kind of saying, saying the same things a little bit there. Um, so you could construct it in a number of ways, right? Yeah, doing meta tables that are as slim as possible as far as no superfluous columns. Yes, different approaches. Yeah, you can try them both and see. Yep. Yeah, it can be hard sometimes. Um, when you have when your tables keep growing, right? I'm sure you start your table is only going to get larger, right? And so yeah, optimization is always a challenge. Sometimes I've had to fight tooth and nail to get somebody to drop a column out of a table, like to not have me pull a column, into a table for something that I'm building, when I know it's going to cause problems. Like a column with a 4,000 character limit. It generated 80 million rows in 5 months. My goodness. Yeah, that's a lot. Wow. Yeah, you're gonna have to do something. Yeah, I can see why you're wanting to do something about that. I wonder, is there any is there any like limit to the history that they want to keep? Because yeah, you're probably gonna have to to do some truncation at some point. Yikes. This year, last year, max. Okay, it's good they've set a max. That's good. At least it's not going to go on forever. So right now at work we've got a data set that we run every night. Um, and originally it was supposed to only store 3 years worth of data, except the owners of the data set, or the business owners of the data set, keep wanting to increase that limit. They're like, oh no, we need one more year. Oh no, let it go for one more year, and then we'll drop some data. And what that's doing is it's causing the data set to run longer and longer and longer every single night. And now it's hitting a threshold to the point where the on-call person is now getting calls that this data set is still running. And we're like, yes, we know, but we can't drop any data and we can't make it run any faster. So yeah, it's becoming a problem. That's what you get when you can't force somebody to set a maximum time limit on the data storage. Yeah. I work around to load the raw clicks when they want to see them with a clicks buffer table that keeps them raw for two. Okay, yeah. Nice. Okay, so let's see. It's after 10 now. Um, this last section is really short. Let's see what's in here. Do we need to worry about this? I think we can actually, this section is really short, so you could probably read it yourself. I hate to bail, but I did say I was setting a time limit on myself for my stream tonight because I need to get better at going to bed at a reasonable hour. So I need to hold myself accountable and hold myself accountable to my own time limits. So no worries, Jampo. Hey, no worries, beer.dev. Happy I was at least able to add some ideas to the conversation. Um, oh, thank you, Nisfornides. Exactly, Rian. Gotta rest up. That's right. Gotta keep a healthy sleep schedule, right? So this last section is really short. You can probably read it yourself. I don't think I read through it already. I don't think that it's super like crucial. I think what we've covered is most of the main concepts, most of the important concepts, most of the important vocabulary. What I would highly suggest is reviewing this temperature converter code again, and again seeing how does it work. What are we doing when we lift state up? How does lifting state up help this app function? And then also too in the last section, section 12, thinking and react, they ask you to build um, they ask you to build like a react version of this search box with a table underneath it. How do they ask you, they tell you how to break it up into components and then build that out. I'm not saying you got to build this thing out yourself. They do show you the finished code at the end. Which is right here. So again, each of these steps are available on CodePen. So just like with Code Wars, when we first started Code Wars, we couldn't do them on our own, but we looked at the solution and we kind of reverse engineered how they got there. And so that's what I would suggest doing with this is looking at what you start with, how they break this out into components, and then looking at where they end up with the finished product and seeing how they got there, where the state is being set, how the state carries from parent to child, and seeing how they break these things up into components and then render them on screen. So that would be my suggestion for how to look at this. But hey, do whatever you want. Just my suggestion. Um, but I would also suggest don't sit down and try to code this from scratch. Just look at the finished product, work your way through it, try to understand the logic, and see how they did this. All right. So thank you all for tuning in today. I hope you got something good out of this, and I really look forward to class tomorrow to see how Leon chooses to introduce React in class. I'm sure he's going to give us a lot of more great resources, things to try, maybe an assignment to do with React, some more reading, something like that. So I'm looking forward to that. Also, as far as the Sunday stream goes, we'll kind of play it by ear. I don't know how long Leon is going to be doing. So super review is Sunday. The conclusion of the super review, he's going to be coding out the binary upload boom code. Um, I don't know how long that's going to take. If he gets done at a reasonable hour, I will probably go live. And what we will do is we will talk through the string methods that he assigned. So he assigned us to define and show examples of various string methods. And so we'll probably do those if he gets done at a reasonable hour. If not, then we'll do those on next Wednesday. So either way, plenty of content, plenty of things to talk about, as always. Super review. Yeah. Oh, no worries, Rianne. Feel like I understand it a bit better than reading it on my own. Yeah, right. And that's again, the point is to not suddenly be a React expert after reading these docs. The point is to, you know, get a feel for the basic vocab, understand conceptually a little bit about how these things work, what they are, what they're for, and kind of have that little spark of recognition when Leon talks about it in class. Be like, yeah, I've heard about that before, or I know what that word means. And remember that controlled components are like a fungus. They're cordyceps. That's all you got to remember. They're an ant controlling fungus and they make zombie bugs. All you got to know if you remember nothing else. All right, let's go ahead and set up a raid. Gonna toss y'all at somebody else. Again, as always, if anybody has any raid suggestions, um, please let me know. I'm happy to take suggestions. But I see today we've got, I'm thinking, let's see, we've got Freckled Science, we've got Team Vash, and we've got Coding with Strangers. I'm thinking maybe we toss it at our friend Coding with Strangers. They are super fun and they always have something interesting going on. I don't know what they're working on. Looks like they might just be getting started. All right, well, we can head over there and we'll see if they're live and say hello to them. Yeah, they are super fun, right? They've only got a few viewers right now, so hopefully they're just starting their stream and we can give them some love. All right, starting the raid now. I'll maybe see you all again on Sunday, and if not, I'll see you all next Wednesday. Have an awesome night. Raiding now.